Okay, it is being recorded now. And okay, so I said individual item reliability is measured. We look at the, if we want to know whether reliability of individual item is achieved, we look at the loadings. And loadings of greater than 0.7 is recommended. But if you have loadings less than 0.7 but greater than 0.4, you leave it if you achieve AVE. But if AV is not achieved, you delete from 0 items to 7. But mind you, I said when you are deleting, don't delete until there is no other items, or you delete until when only one item remain. I could remember there's one guy that has 50 items in a construct, only 4 were left. Crazy. But he is saying he is measuring the construct. Is that one, it doesn't work that way. You just have to now total it. You have 4 items, 4 construct with two items. That means you have 8. So maybe the thing that you just calculate how many, only one can be deleted out of it, something like that. So in that case, that's it. Then when you are measuring the cost validity, we talk about convergent validity, and we said the AVE. AVE is a variance, average variance structure. That is, when we add up the total of loadings and divided by the number of loadings, the number of items, it will give us the AVE. And in that case, it should be greater than 0.5. And it's less than that, you have to achieve it before you move further to any other analysis. Then we talk about discrete validity, and we told you that there are 3 ways through which you can understand, or you can know whether discrete validity is achieved or is not achieved. And one of them is Funnel and Lacquer criterion, and the second is cross-loading, and third is HTMT. And if you remember, we did talk about all of them one by one. The first one we said, okay, let me just give you a recap very small here. Okay, this is the model we did yesterday. Okay, let me just show you again, once again, so that maybe very in a vivid way, so that you will understand. We can have 8 minutes to recap. By the time we finish the 8 minutes, we'll stop. Okay, so this is the funnel and lacquer. If you see on a discrete validity, here is discrete validity, and there are 3. One, funnel and lacquer criterion, cross loadings, and HTMT. What I said on funnel and lacquer is that any number at the top, that is diagonal number. When we say diagonal, it goes something like steep. Okay, yeah, from up it goes down. So all the diagonals, the number at the diagonals, the first number at the diagonal should be greater than what is down, and should be greater than what is left. Any number that is greater than what is up or down, or up or right, meaning that there is issue of discriminability using funnel and lacquer criterion. Then we move to cross loadings. We talk about, if in the cross loadings, what we check is that we look at the items loadings on other constructs. Okay, for example, we have authentication. Authentication items are 6. So we want to look at the correlation with the other items in the same model. For example, we have authentication 2 is 743, 63, authentication 3, 639. So we want to expect that all these items should load on authentication more than on privacy, security, trust, and use. Another example is if you have okay, passive privacy PP has 3 items, and this is the concept of privacy. So what we are expecting is that all the other value on the right side of it, that is on other construct, on the left, at the top, at the bottom, should be less than the exact loadings of that construct. That's PP1, PP4, PP5, something like that. I don't know if you understand this one. Okay, we did it yesterday, so you supposed to understand anyway. So the next one is HTMT, and this is the most important because a lot of people are reporting it, and is the most current and the most useful discriminant validity criteria. And there is the one that if you don't report it, you will have a question to answer there. How are we going to know whether is achieved or not? Is that you look at the all the values in the table. Is there any value greater than 0.9? If there is, meaning that there is discriminant validity using HTMT. If there is no, then you achieve HTMT. Or there are two thresholds by two different people. One said 0.9, the other said 0.85. The most conservative is 0.5, and the most liberal is 0.9. So a lot of people are going for the liberal because some of their model is not achieve 0.5. So if you don't achieve 0.5, you now say, okay, 0.9, because another literature says 0.9. I think the literature is a Klein et al. And one other person called Gold et al. I think, okay, yes. Klein et al. He said Gold and et al. say 0.9, while Klein et al. say it should be 0.85. And okay, that's it. And the last one is there is another thing that we will do it when we come to the main, what's the name? Structural model. When we test structural model, this HTMT inferences is where we get it, because we have to run bootstrapping to get this HTMT of our lower level confidence interval to know whether is achieved or is not achieved. This two sometimes is also the most liberal anyway, the HTMT inference. If you don't achieve any of this 0.9, 0.85, then you go to HTMT inference and look at if is offer level confidence interval is less than 1, then you now say you achieve HTMT. But I believe a lot of people are using HTMT ratio to show whether it's achieved or is not achieved. Okay, the next is
excuse me, Doctor, where to look at the table for HTMT?
okay, you want to see it here or what?
Yeah, I mean, how to recognize whether it is achieved or not?
Yeah,
Which number we should look?
yeah, see,
Because there are so many numbers.
yeah, okay, so please, this is an example I gave you yesterday. This first one, uh, you look all the numbers in the table, all the correlation in the table should be less than 0.9 or 0.85.
Okay,
Yes, all the numbers
okay,
should be less than that. Okay,
okay,
and
thank you.
but you should be mindful about once and again. You should look at the correlation between items and between constructs. Correlation between items should be higher than the correlation between the construct and items of another construct. Do you get me?
Okay, yeah,
Yes.
yeah, okay,
Okay,
so
so that's it. So admitted. Okay, thank you. Okay. So I okay. Hey, let's go further. Okay, so this is all about this HTMT and discriminant validity criteria for assessing criteria for assessing structure measurement model. So I think this is all we cover so far as measurement model is concerned as per yesterday. And today we are going to move further to see how we can deal with formative construct. You know, all what I did yesterday was they were measurement model assessment, but reflective items. Today we are going to talk about formative items. We told you that formative items are the items, a formative construct is a construct that has items that are forming the construct, not the construct forming the items. Okay, and we gave example. I believe you must have understood the example that we gave yesterday. So when we are assessing the structural model formative items, there are two types of it. One, they call it causal indicators, while others are they call it composite indicators. But before we talk about causal and composite, these are some of the things, these are the things that we should measure if we want to know whether we achieve measurement model or we do not achieve measurement model. We look at the weight, and the weight of all the items is an opposite of loading anyway. In reflective items, we talk about loadings, but informative, we talk about weight. So weight should be greater than 0.1. So, and we don't know whether it is okay or it's not okay until we run to know the level of significance. Is it significant that it should be significant greater than, it should be less than 0.05? And now, again, we look at the multicollinearity. In that case, we look at variance in inflated factor. And we now say BIF should be, BIF, that's a BIF, should be less than 5 or less than 3.3 according to various literature. The last one is we look at the convergent validity. Convergent validity in informative is what we call redundancy analysis. And when we run the redundancy analysis, we expect the beta value or the fat coefficient or the weight, the beta value or the fat coefficient should be greater than 0.7. Should be equals to or greater than 0.7. If we have that, we now say this formative construct has all the necessary requirements to move further for further analysis. So in this case, we are going to we go to back to our model and see what we mean by this formative indicators. So in this case, maybe you can, if you are ready, you open your Smart PLS software, and we start. In this case today, there should be a minimum show. When I say show, I mean minimum sharing. So please try to just understand, because we really have a lot to cover, but we don't have time. Okay, yesterday, this is the model we created, and we were able to satisfy the requirement for measurement model in reflective items. Okay, so we will show you what we mean by formative items. It looks something like this. For example, we have use. We are going to model. We want to model use as a reflective formative items. In that case, what we should do is we just right click inside the construct, that is this inside this blue cycle, and say switch between formative reflective. Then if you switch, then you will see the arrow are going into the construct. Before it was like this. the arrow are going out to the items. But now the arrow are going into the construct. So if we see anything like this, meaning that the items are formative in nature. So in that case, then the first thing that we said in the slide, we did say that we want to know the weight should be greater than 0.1. How are we going to know that? We run the PLS algorithm as we did yesterday. Run PLS algorithm, then we say start calculation. In this case, we look at it. So we look at the use. Are all these greater than 0.1? The answer is yes. So the first condition for a formative indicator is achieved. All of them are greater than 0.1. But we don't stop from here. The next we want to know, is it significant? Okay, so if we want to know whether the items are significant, this is what we should do. Let me just share something. Maybe we will have to do it again. Okay. This is the test of significance, but we are this should have been done in a structural model, but because we just have to know the significant level of the weight, that's how we are going to do it. We run the test of significance, and we want to know whether it is significant or not. And to know whether it is significant or not, if we run, we expect the value to be greater than 1.64, or it should be at least 5% significance, this one. So let's go back to it and see. This is the model, and these are the items. So we want to know whether this one should be greater than 1.64. We want to expect all this. If we run test of significance, we expect them to be greater than 1.64. If it's less than the 1.64, meaning that the second assumption is not achieved, then you have to think otherwise. Okay, so we want to test for significance. We will show you this one also again, but if we want to run test for significance, we calculate bootstrapping, and we run just what, okay, just start calculation. You don't have problem. Bootstrapping, stop calculation. Start calculation, sorry. Okay. This is what we have. The first thing is achieved. We have greater than 0.1. So when we run for significance, these items I told you should be greater than 1.64. How many are they? How many of them are greater than 1.64?
Dr. Salis,
Yes.
are you looking at construct one by one, on only, for example, use?
No. You are looking. We are looking at the items one by one.
Not
Yes.
all of them, yani.
No.
If I compare security, use to trust and authentication, definitely, and privacy, definitely they have different values.
No. We are talking about only use the items 1, 2, 3, 4, 5, 5.
So in this case, in this case, you are measuring item one by one.
Yeah, we are
construct one by one.
Yeah, we are talking about the measurement model, that is the relationship between items and construct. Is that understood? Okay. So if we look at this one, how many are significant here? I will say it should be greater than 1.64. So how many are significant here? Can anybody tell me?
Only two. One and two. One and two.
Yeah, only 1 and 2. So meaning that the second criteria is not achieved, right? What are we going to do then? What the next step? The first is achieved, the second is not achieved. What we should do is now here you cannot delete, you know. It's unlike a measurement model using for reflective items, you can delete if it's not achieved. But in formatting items, you cannot delete any because they are part and parcel of the construct. So meaning that you cannot delete any one out of them. So, but it's not achieved. What can you do? Any idea? What you can do is that you go back and check the loadings of these particular items. Are the loadings greater than 0.6? You leave them. If they are not, then you have to think of somehow going back to your drawing board, meaning that you have to make it like going back to pre-test. Maybe from there, that is where you skip some procedure. That's why it doesn't work that way. Deletion of items, formatted items, is not easy, especially when you have what they call composite indicators. If you have causal indicators, I will talk about them. You can delete because it's not complete.
Sorry, sir.
Yes.
You said we go back to check the loading of each of the items.
Yes.
If it is greater than 0. What?
It is 0.6.
6. Thank you, sir.
Yeah, if it's greater than 0.6, you leave it.
You leave the item.
Yes, exactly. You leave the item. You leave the item. Okay, that's it. Okay, so now we are going back to check whether the items loadings is okay or not. Maybe we go back to report and see and look at the items loadings. I think we can now go to, okay, we run the PLS algorithm again. Go back, run the PLS algorithm, look at start calculation, then you go to report. Okay, when you go to report, there is down here, there's outer loadings. Okay, you click outer loadings, and under outer loadings, you look at the items for use. Okay, you see, item number 4 is less than 0.6. Still, in the item loadings is still less than 0.6. So in this case, you may be considered deleting it, but based on theory or based on a thorough literature understanding or based on context, something like that, because there are some constructs that are formatted in nature, but some of them you don't, contextually you cannot use them. So maybe you can give that justification that because they are not part of my model, I delete them. They are not part of my context, I delete them. So something like that. But if it's not achieved, then you have to know how to do all of it. But other people are saying if you have formative construct and it's not achieved, you cannot delete. You just have to leave them like that. So, and that's why formative constructs are very crazy construct. Yeah, they are very crazy construct. Okay, because you can easily achieve validity and reliability in reflective items, but sometimes, most of the time, sorry, you just have to get you will have problem with a formative indicator. Okay, so in this case, if we go back to our model, we found out that they are all okay, but in the second stage, they are not okay. And we found out that the one of them has loading below 0.6. So, but in this case, we just have to leave them. That is, according to another literature, that you have to leave them. Because it's a formative indicator, you cannot delete. But you just have to mention somewhere in your study, in your work, that because they are formative, you cannot delete them, and they are very important in your work. So therefore, you cannot delete them. Then you go ahead and leave them. but you just say it's not achieved, you leave it, that one will create a trouble to you anyway. I did told you that there are two types of formative, causal and composite. When we say causal, we are talking about there are some specific type of formative construct that if you have them, you can delete an item. Why? Because they are not completely, you can add something to it, meaning that this construct, they are for example, another study come and add one, another study come and add one, meaning that you can add. So although they are formative, but you can add something. So in that case, you can delete, but they are, remember, they are not reflective. What differentiated between between composite is that composite are complete of it, 100% items. You don't delete anyone. Okay, I give you example. If maybe those who are in the marketing department, they should know what is called 4 P's. That is product, price, place, and one other thing: product, price, place, and
promotion.
And promotion. These are called marketing mix, and is being modeled formative construct, but they are composite in the sense that do we have anybody that says marketing mix are 5 now or 6?
But there are 7, so even more.
Okay, so
in service marketing. Yeah, so the 4 are for physical product marketing, sir.
Okay, so
maybe in that case, okay.
Yeah, the understanding is that they are fully encapsulated into the construct. You understand? Yes. You don't have any other thing that remain. That is R square. I don't want to say about it because you may be confused. Okay, is fully captured. The construct is fully captured by that item: price, product, promotion, and place. They are 100% capturing that construct. In that case, you cannot add anything, you cannot remove. So if you cannot add, you cannot remove, they are considered a composite indicator. But in a situation whereby you can remove some of them, for example, okay, let's talk about that food, fries, whatever. Everywhere in the world, it is generally accepted that wherever you go in any context, they remain the same: product, price, promotion, and place. But other construct, you think maybe they may not be relevant to your context. Okay, you will now think that maybe you have 4 items. You now say you now, based on literature, based on your understanding, based on expert advice, you now think this one is not should not be part of my model. So you can delete it. It has now become a causal indicator of formative construct. So these are some of the examples, so you can read further and you understand it well. If you want to know whether you just cannot delete just like that, you have to have a lot of justification why you delete them anyway. Then I told you you test for significance. It should be greater than 0. It should be greater than 1.64. Then you check for collinearity because they are formative construct. We need to know whether there is correlation. If you remember, like yesterday, we talked about correlation of a formative construct should not be correlated in any way. It should have low correlation. But if it is for reflective items, we need to see high correlation between items. But formative construct, very low correlation. Okay, so in this case, we run what is called multicollinearity test. That is, we want to check the VIF. And you don't need to go back to SPSS to check for BIF. You just go down, you run the PLS algorithm, something like that. This is calculate PLS algorithm, then you start. When you start this one, you finish, then the next is you want to know whether there is multicollinearity or not. You check for BIF. The BIF is here. Go to report, then collinearity statistics, then you look at the BIF. This is the BIF. And now, because all you need is the BIF of your formative items. What are the formative items are used? Used are the formative items. This one, 1, 2, 3, 4, 5 are formative. So you look at the BIF. Are they greater than 3 or greater than are they greater than 5? If they are not, then you accept, you achieve there is no collinearity between the items. If they are okay, the two school of thought says, some of them say it should be 5. For example, here I tell some say it should be greater than 5. But there is another person called Demontopoulos and Sugue, that's 2006. He said it should be 3.3. Okay, so you choose between conservative and liberal. If you choose the liberal, then you go for 5. Okay, so now you say, if you look at this one, if both the two are considered, both the liberal and the conservative, is achieved here. So you now report in the report that is achieved. The next, you check for the convergent validity. This is a new way of testing whether the items are okay or not. How you run redundancy analysis is you have a construct that is formative. The first thing that you do is try and get another items that are reflective in nature, that measure that same construct somewhere. That's, for example, you have satisfaction. Let me go back here and see. Here we have, okay, satisfaction here. Okay, satisfaction here is measured using two ways: reflective and formative. So if you are using satisfaction as your model, and you use them as reflective, you want to measure redundancy analysis, you have to send the items using the two constructs: reflective items and formative items. If you do that, that means you are collecting the two data on one construct. First data are reflective items. The second data are reflective formative items. Then when you come to analysis, then you test whether there is high correlation between the two. If there is correlation, high significance level of the part coefficient should be very high. And some people are saying, the literature says it should be greater than or equals to 0.7. So meaning that you are testing the relationship between formative indicator to reflective indicator, something like that. Let's do it here and see. Okay, so this one is this one, okay, this trust and this one and this one. We are deleting this one. Okay, for example, supporting this one is also okay. Wait, okay. Let me just rename it as use. Okay. Okay, maybe use formative, reflective. Okay, use reflective. Okay. So supposing we collect the two data of use having two. The use is formative, and we want to test whether there is item redundancy. Some of them are not working. Then we test the redundancy. We do redundancy analysis. This redundancy, we try to relate the reflective items to formative items. If these reflective items are fully predicting the formative items, then we say we achieve redundancy analysis. For example, when we say run, we run it and see whether it is high. Okay, in this case, we have 0.444. But literature says it should be 0.7. Some people are saying it should be substantially significant. Substantially in the sense that it should not be just something 0.1, 0.2. It should be substantially. Maybe we can consider this one as okay. So this is how you run redundancy analysis. This is one way. The second way is that you should collect data using what they call global item. Global item is one item that you add into your questionnaire that talk about the overall of your items. For example, here we talk about satisfaction. Okay, where is it? Okay, here we talk about satisfaction, and we did say that. Okay, I appreciate this hotel. I am looking forward to staying in this hotel. I recommend this hotel to others. They are all what? Reflective, for example. So if we need to have a global item, we now say, generally, how are you satisfied with the hotel? This is called global item. So it means that you have one item that almost measuring everything. This is what's called global item. So in that case, you now use that global item to predict your formative construct, and also that one should be greater than should be equal or greater than 0.7.
So sir, you have to go back to collect data for that global item.
No, you collect with it before data collection.
Okay.
Yeah, you are going to put it in your data on yeah, from the onset. Yeah, if you don't do that, meaning that you just have to do that. So there's other ways anyway that if you don't have the data of that construct that you should collect, you didn't collect, then there is other ways, but it's beyond this workshop. But these are the two ways you test the redundancy analysis. But not everybody is showing it in their work. If you check some of the papers, very good paper, you find out that they are reporting only 3 things: weight, significance of weight, and multicollinearity. If they one is satisfied, then they will say, okay, satisfied. The redundancy analysis sometimes is not necessary, especially if you write in paper. Anyway, I see a lot of people that don't report it. So please, ladies and gentlemen, I don't know if you understand this one clearly. If you have any question, do ask. If you don't have, then we move further.
Okay.
Okay, so please let me check the chat box. Somebody is saying, okay, good morning, assalamu alaikum, good morning. Okay, what's the difference between one tail and two tails? Okay, please, we are all coming to that. This one is not in the measurement model. We are talking about measurement model now. So please, we just wait. We are going there. Gradually. Okay. So any question again? Please, I want you to understand this, because one day you may want to write a paper that has maybe somebody want to write a paper on a formative construct such as marketing mix. So if you are writing on marketing mix, you should be ready to test all this. Now don't say that, okay, I have items, all my items in my PhD are reflective, so I don't need it. You might need it one day. Or if your lecturer or student would ask you how it is, are you going to tell them? Are you going to tell them, I don't know? It's very embarrassing. So please, if you understand, okay, let me know that you understand. If you don't understand, please let me know as well. Okay. Okay, silence is assumption that is.
Sir, sir, excuse me.
Yeah, you are excused.
What about second order? We need to understand that.
Please, We are still in the process of going there. Look, just go back and
Okay.
look at the table of content, what we are going to cover is there. And it should be the last one that we're going to talk about. Yeah, please, we are going there.
Okay.
Yeah, we are going there. Inshallah.
All right. Thank you. Thank you, sir.
Okay, no problem. Inshallah. Okay, so any other question? No question. Thank you so much. We are going for that. So, ladies and gentlemen, we want to assume that our model is full of validity and reliability. So the next is we want to see whether what we hypothesize is according to our wish or against our wish. We want to know whether what we propose as our hypothesis is accepted or rejected, is supported or is not supported, is significant or not significant. This is what we are going to do now. And this was called assessing structural model. Okay, there are so many things that we do to assess this measurement and structural model, and you also listen attentively. And I want to tell you as well, please try and put more grease to your learning, number learning faculty, because here there are a lot of numbers as well. Also, more than the numbers you mastered yesterday. I don't know if you mastered it. Okay, sorry. Okay, so you remember last time that we said what is structural model is that we want to test the relationship between constructs. All what we did yesterday, we assess the relationship between items and constructs. Now we are going for construct to construct. What is the relationship between construct and construct? And this is your main focus. Significance. You want to achieve significance. You want to have your hypothesis all supported. You don't want your hypothesis to be rejected because you don't want to talk about it in chapter 5 or something like that. Okay, so this is why you want to know it. You should. That's where you should know it. So, if you as assessing structural model, there are so many ways that you should. There are so many things that you have to consider. Maybe in assessment of a measurement model, we have almost 6 or 7. Here we also another 6. We have also another 6. So get ready to know them one by one. Unlike CV same, you know, when I say CV same, I mean unlike software like Amos, that you go for what they call standard goodness of fit statistics. In CV same, there are some statistics that are called goodness of fit. Goodness of fit, or they are model fit indices such as they call it GLI, TLI, Ramsey, chi-square, NFI, a lot of them. All these you must achieve it in CVSM to achieve the goodness of fit. But in PLSM, your aim is not that you want to test theory. In this case, you assess your model quality based on its ability to predict the indigenous construct, endogenous, sorry, I beg your pardon, endogenous construct. When you remember yesterday, I told you, when we say endogenous, we mean any item or any construct that has arrow that goes into it. In this case, when you look at down here, the arrow between X and Y is going from X to Y. In this case, our Y here is called endogenous construct. So we want to know the ability of this X to predict Y, meaning that these are what they call the model assessment. So the first thing we do is, okay, there are 6 assessment criteria we should adapt when we are assessing the structural model. The first one is we evaluate the structural model collinearity. You remember here we are not talking about items. We are talking about construct. So in this case, we want to test the collinearity between the constructs, not between the items. Okay. Now, number 2, we examine size and significance of part coefficient. What is part coefficient? You remember we said is the beta value, the number that appears between X and Y when you run PLS algorithm. The first time you run PLS algorithm, which number appears? It should be less than 1. So this is called part coefficient. We want to know the size and we want to know how significant the size is. That is number 2. Number 3, you look at R square. What we talk about R square of the endogenous variable, they call it in sample prediction. What we talk, what do you mean by R square is we are talking about the total contribution of all your IVs or all your exogenous variable to the endogenous variable. Then you will look at the effect size. The effect size is talking about the contribution of each item or each construct to the R square. Then we go for predictive relevance, that is relevance of our prediction, and we go for prediction, relevance of prediction using 2 ways: predictive relevance and predict PLS predict. These are the 6 things that we are going to discuss one by one, and we hope you can do that in the next 2 hours. Yes, 11, 12, 1. Yeah, so we have a lot of time. So I think okay. All right. So next we are going to talk about a test of significance. The first things in the things that okay, so okay, test of, okay, yeah. Sorry. Okay. The first thing, no, test of significance. Okay, yeah. This one. Okay. After this one, then this one. Okay. So the first thing that you remember, whether you are using reflective or formative items construct, this is what you should do. You as far as variance inflated factor is concerned. You remember when you say variance inflated factor, we're talking when you say VIF, it means variance inflated factors. So according to this here until 2011, he said VIF statistics are important for inner model and formative outer model, that's measurement model. It's important for both reflective and formative outer model. Okay, well, I beg your pardon, not like that. It's important for inner model of both formative and reflective, and is important for outer model for formative construct. When we say outer model, we are talking about the measurement model. Okay, BIF statistic is important for the relationship between X and Y, both in formative and reflective model. But it's very important, it's also important for the relationship between items and construct if the construct is formative in nature. That is what number 1 is talking about. Number 2 is saying if the model has only reflective measures, then use only in the BIF model. That is just explaining what I told you. If you have all your model has reflective items, then you don't need outer BIF. you don't need the BIF of all the items. Okay, you need the BIF of all the construct. But if the model has formatting measure, then you assess the BIF of both the formative, the indicators and the inner model. In other words, if your model has reflective items, you measure only the relationship, the BIF in the relationship between X and Y, for example. But if you have formative, you have to measure two BIF. BIF of the first state, that is the BIF of X and items, BIF of Y and items. Then you now again test the BIF between X and Y. So there are a lot of threshold that says, if you told you before that here at 2011, he said BIF should be less than 5, or according to Diamantopoulos and Sigwe 2006, BIF should be less than 3.3, and that's a two extreme. Number one is more conservative, and number two is more liberal. So you now choose, and you look at your model. If you have 5, you go for hair gel. If you have less than 5, I beg your pardon, maybe you have 4.5, 4.6, 3.9, then you now say you follow Airtel. But if you have less than 3.3, and maybe all your items BIF is 1.6, 2.9, all less than 3.3, then you now say you follow the Diamantopoulos at 6, and you said BIF of the reflective or formative inner model or outer model is achieved.
Hello, sir.
Yes, sir.
If prior studies in your area of research had used point less than 5, but in your particular study you have less than 0.33, you have to use Diamantopoulos and Sigwa 2006. Yeah, what justification do you use? Because prior studies.
Please forget prior study.
Okay, sir.
Yeah, you should concentrate on those who make the matrix. Okay, you concentrate on hair and the Diamantopoulos. Okay, if your own is greater than 5, is less than 5, just you can choose hair. If it's less than 3.3, just choose the Diamantopoulos and stop here. If your reviewer knows the issue of BIF well, if you cite these two people, it's enough for him to surrender.
And what about Viva? What should we adopt, and what should satisfy the examiners?
What?
What about the Viva? What should we do, and what should satisfy? Which number should satisfy the examiner?
No, see,
your results.
You're actually okay. Somebody is okay. It depends. See, that's what I said. If your supervisor or your examiner really knows what is VIF, and he knows that you can go for either less than 5 or greater than 5, it's okay. You have justification already. So what are you afraid of? Your own is is greater than 3.3, and now you cite here, and nobody will ask you, because here already said it. You know, here in PLS, when you say here, then please not here on your head anyway. When you talk about hair in modern SEM, then everybody will now keep mute. Whoever the hell is the guy, I don't know. Maybe if he is not yet, we don't have number 2 yet anyway. So if your own has less than 4, less than 5, greater than 3.3, just cite here at 10. if anybody asks you during Viva or in your review that your one is less than it should be less than 3.3, you now show them here says it should be less than 5. So I am following here. I am advocate of here, not the
Dr.
emperor.
Salisu.
The Montopoulos, yes.
Excuse me, Dr. Salisu.
Yeah.
There's one participant waiting to be approved.
What?
One participant waiting to be approved.
No, I approved him already.
Approved.
Yeah, I
Okay.
approved him already.
Just now.
Yeah, just now I approved him.
Okay.
Before I start this one, I approved him. Shakir, right? Yeah, I approved him.
Yeah.
Yeah, I approved him.
Thank you.
Okay. All right. So this is it. This is all about the BIF. BIF is not more. Is more or less talking about if your items have a relationship, too much relationship, or if your construct have too much relationship. That is what we don't want in analysis, in research. You are measuring two things, it should measure two things. You don't take two things the same and say you are measuring another things. You are measuring one then. Why don't you just measure one and forget it? Do you understand? So that is it. So this is what it's talking about, variance in predictive factor. So if there's no question, we move further. So then the next is we're going to look at the okay, where is the next is the size and significance of part coefficient. Okay, what is part coefficient? The part coefficient I told you is the number are the numbers that you see between X and Y when you run your PLS algorithm. Okay, and it should be your hypothesized relationship. It links the construct. Okay, and the beta value should range between 1 to -1. Okay, maybe you should have 0.0. Okay, it should not be more than that anyway. It should not be more than -1. It should not be more than -1 as well. It should be in between 0.9 minus 0.9. Okay, 0.2. It should not be greater than 1 anyway. Absolute value of 1, meaning that it should not be 2. It should not be 2.5. It should range between 0.1 to 0.99, or from 0 to 0.99 or 0.1. It should not be 1. Okay, so but how do you know that there is strong relationship? We look at the value. The closer the 1, the more strong the relationship. Okay, if we look at 0.1, 0.2, 0.3, 0.4, 0.4 should be more stronger in terms of significance than 0.1. Okay, so let's do it. Let's do two things so that you understand on the model what I mean. Okay, the first one. Okay, okay, let me go back and make it the way it is before. Okay, this is how it is. So we want to test. The first thing that we did, we want to test for BIF. If you want to test for BIF, this is how you say calculate PLS algorithm, start calculation. Then you go to report and click BIF. So if you have, according to what we said, if you have formative construct, you look at the both outer and inner BIF. If you have reflective, you only look at the inner BIF. You don't care whether the outer is okay or not, because the reason is that outer BIF, we expect the item to be highly correlated, so we don't need it. But in formative construct, we don't expect any high correlation. So we try to check it. So in this model, we look at here, we look at the threshold is 3.3 or 305 according to here, or the multiplus and get 6 respectively. So in this case, do we achieve this segment or not? Do we achieve BIF? I am asking question. Do we achieve BIF?
Yeah, all the values are higher than 1.
No.
1.1 is 1.11.
No,
Yes,
no,
sir.
no,
It's
no,
achieved.
they-
It's achieved based on. It's achieved based on the here is all the values are less than 3.
no, they are
Based on
not achieved.
the
They are not achieved. They should be between 1 and -1. So they are not achieved.
No. We are talking of VIF. VIF based on the multiplicity, which is very stringent, is less than 3.3.
No, we are talking about beta path coefficients, aren't we?
Oh, I thought he's talking
No,
about
no,
the
no.
VIF
See,
first.
we are talking about VIF. Look at the VIF
Okay.
here. Collinearity
Yeah.
statistics.
Yeah. For
Yeah.
VIF is achieved based on Diamantopoulos and Sigo 2006.
Yeah, that is
All
what
the values are less than 3.3.
exactly. All the values are less
So the
than
VIF is
3.3
achieved.
is achieved.
Yeah.
Thank you. So
You're welcome.
what of the outer model also achieved? And now this software gives you very simple way of understanding it. They give you value of,
color.
in color.
In
If
color.
green, all green, maybe will tell us this one. That's the only thing she knows. If all green achieved, all green significant. Okay, so if all these are all green, meaning that it's achieved. If they are black, they are on the wall, meaning that they are very close to going red. But they leave blue. So if they are black or green, it's okay. But if they turn red, that is blood. Very unfortunate. You just have to think otherwise. You have to go back and think your model and look at the measurement model, how you can improve the statistics. That is VIF. That is the BIF. The second one is the test of significance. You understand? If you remember, we say if we want to test significance, we run calculate PLS algorithm and start calculation. And if you remember, we said, okay, please let me not confuse you with this stuff. All this, we are no longer dealing with items. Okay, we are no longer dealing with items. Items, we finish with them. That is, we achieve everything we want to achieve. In this case, we want to close them. We don't want to see them here because we are dealing with their mothers. Okay, they are no longer, the children are no longer needed. So we can hide them somewhere. We don't want to see them. Look at how you do. You right click, you say hide indicators of all construct. In this case, when I click, it will make everything hidden. Okay, so that's it. So now we are talking about this. Okay, well, let's arrange it in this way so that you, okay. We are talking about these numbers now. These numbers, we said this number should be between 1 to what? 0.999, between 0 to 0. Between 0 to 0 to between 0 to 1. Sorry. Between 0 to 1.
1.
Yeah, 0.1 to 1. Sorry, between 0.1 to 1. The closer the 1 to 1, the closer it is to 1, the more significant.
The more stronger.
The more stronger the relationship. Okay, in this case, here we have the security, from security to use, we have 0.248.
24.
Yeah, meaning that is greater than 0. Okay, so we can, but it's still not
Weak.
very close to 1. Okay, but it's okay. Yeah, so this one is also
0.247.
yeah, 0.247, 0.28, and this one is 0.99. Please, we are talking about absolute value. We don't care about the negative or positive. Do you understand? Okay, let me make it clear for you. Can anybody tell me what the difference between negative and positive beta value? If we get here, we get positive here, all of them positive. But this one is apparently negative. Do you have any idea about this?
Not the relationship, the direction of relationship.
Okay, something like that, yes. Okay.
Negative relationship between privacy and use means that there is
correct.
there is no.
That's absolutely correct, but it's not that there is no relationship, but the relationship is negative.
It's negative.
Yeah, it's
like
negative.
Inverse relationship.
Yeah, it's negative. No, it's not inverse. We don't call it inverse because
okay, it's negative. Okay.
Yeah, we don't know whether we look at our hypothesis. Yeah, if our hypothesis says there is negative relationship, meaning that this one is okay, not inverse. Yeah, but if our hypothesis says there is positive relationship between privacy and use, then we get negative, that's when we get inverse.
Inverse, fine.
Yeah, something like that. Please, ladies and gentlemen, other participant, Ramash, are you with us?
Yeah, doctor, I am with you.
Yeah, today you don't ask questions, so I
No, I am observing you. I am actually teaching right now, but then I am also watching your stuff.
Okay.
Okay.
So please try to understand, okay? All right, so this is it. In this case, we have, these are what we call path coefficient or beta values. Okay, these beta values tell us whether the relationship is negative or positive. And we expect it to be substantial for the hypothesis to be significant. So, but here we don't know whether it's significant or not. We only know that the relationship, 3 of the relationship is positive, one of the relationship is negative. That is all it tells us here. And this is one segment of it. We call it, we said, okay, this one, examine the size. We are only examining the size now. We don't know whether it's significant or not. So the next is we want to examine the significance. This is what we do. Okay, up to this point, please, ladies and gentlemen, are you clear?
Yes.
All right. So the next is we move to test whether our relationship is significant or is not significant. Okay. So this is how we do it in this PLS. A very simple way. You will now say calculate. You go to bootstrapping. This time around, we are talking about, we want to know the level of significance. And you know, if you want to know the level of significance in PLS, you run bootstrapping. And how bootstrapping works. Some people will say if you use bootstrapping, Propramaya once give us one story that when he said you proofread, no, I beg your pardon. When he say you bootstrap, you are doing what is haram. Somebody attended his workshop when one of the participants said, according to his understanding, bootstrapping is haram because we are putting more data into your model, which is not collected in the field. So he said that one is, according to Islam, is haram. You understand? So, but he made him understood that it doesn't work that way. Bootstrapping is not adding your data. It's not multiplying your data.
Substituting.
Yeah, it's not substituting your data. It's not substituting your data. It's only okay. Okay. How should I put it? Not substituting. It's only making your data, picking your data at random and calculate it. You understand? He ran your data different times. Okay. For example, if you have 1, 2, 3, the first time you run your data, it takes 1, 2, 3, or 3, 2, 1, or 3, 2, 2, up to certain times. For example, if you we run, let's start and see, maybe you understand better. We bootstrapping. Now you look at here. This we click bootstrapping. In this case, we have a subsample, 500 subsample. That is where that guy was arguing that it should not be. We should only put the number of our items. But Ramaya advised him that it's no. This is how it should be. Subsample is not that you are duplicating your data. No. So you should take it back at back of mind that you are not duplicating your data. You are just resampling your data. It's, you are using the data, you resample the data. That is the correct word I want to remember. You resample the data. You resample in the sense that the first instant you generate another sample, you generate using your data, not outside data. That is why it is not that haram as you may think. It's not unlawful as you think. It is not. Okay. So here, when you want to run, to see whether your data, you have your relationship is significant or not, you now say calculate, bootstrapping. Then under here, what you should do is you just look at the subsample here. 3 literature exist. One of them say you can use 500. This is by default is 500 here. Others said you can use 1,000. Another say, and other people said another people say you can use 5,000. And the new literature says you can even run it up to 10,000. Depending, because it's very, you are resampling your data is very large. So that you should know that if you don't have a very good, strong and efficient, fast computer, don't run 10,000 because it will hook your computer. Because it's running so many 10,000 sample. It will sample your data. That one data, if you have 100, for example, you have 400 data as your sample size. So it will resample the software will sample your 400 data 500 times or 1,000 times or 5,000 times, or it will resample it 10,000 times. Just imagine if it sample is 10,000 times. If you don't have a very good processor, your computer may hang. That's why sometimes you should just go for 500.
Okay, excuse me, sir.
Yes.
Excuse me, sir.
Yeah, I can hear you, sir.
Okay, at this level, the choice of 500, 1,000, 5,000, and 10,000. What is the effect of that on the result? Because if there is a difference, and a lot of people have a system with low capacity, it means like there's a threat of what should we do?
See, please, nothing like that. Sometimes the result will remain the same. See, sometimes you even get more result when you test for 500.
Okay.
You understand? Maybe we will run the two, you
Yes.
will see how it work. Okay.
Okay, then what is the idea of asking for larger subsamples if 500 is sufficient?
Okay, so maybe that one you can sometime. Okay, we are testing for accuracy.
Oh,
You understand? The more sample you have, the more accurate you get your result.
the results will be okay.
You understand? The more accurate your
Yes.
result will be. So that's
Yes.
why sometimes if you have 10,000, it will be more
Mhm.
accurate than having only 5,000, 500.
5,000. Okay.
You understand?
Yes.
Yeah.
And you need to report that you use 5,000 subsamples of
you
this in a
you
paper.
you need to say
Okay.
you use 5,000 or other people are not reporting anyway. I see some used, but I see a
Okay.
lot of people that don't use it. They just
Okay.
say they use bootstrapping subsample.
Okay, fine.
Yeah, but you should know that the more you use, the higher you put the number, the more accurate your result will be.
Okay, sir.
So maybe sometime that is why sometimes if you put 500, you will get more result than 10,000. You know why?
Okay. No.
Yeah, because 500 is not that full accurate.
Okay.
Yeah,
Okay.
if you go
There
for
are some
500,
noise
what is significant in 500, it will come back non-significant in 10,000.
in 10,000. Okay.
Yeah, because it's the higher you go, the more accurate it be.
The more accurate it will be. Okay.
Exactly. Okay.
Thank you.
Yeah,
Doctor,
yes, doctor.
just one more.
Yeah.
On the left side there, we have explained sufficiently about the sample, subsample.
Mm.
The recommendation is that we should leave basic bootstrapping, bias corrected,
Yeah.
and one tail. We
See,
should leave those ones like that.
yeah, I am coming there.
Okay, sorry, sir.
Yes, I am coming there.
Okay.
Okay. The next thing is you look at the amount of result.
Okay.
You see, if you go for basic bootstrapping, there are some parameters that it will not show. If you say full bootstrapping, it will show everything that is needed. So for just testing of significance, you don't need complete bootstrapping. You only need basic. But there are other things. For example, if you need for the confidence interval of HTMT, something like that, you just have to go for complete bootstrapping to get it. Yes. So, and then you go for the confidence interval method. You should also be there as bias corrected and accelerated. Yeah, because it is the best one. It corrects the bias you have. So by default is basic bootstrapping, bias corrected. You leave it like this. Then when you come for significance level, oh no, test type. That is where you specify whether your relationship is one tail or two tail. What is one tail and two tail? It's something like this. When in your study, you say there is a relationship between A and B, or there is positive relationship between A and B, you are talking about one tail, two tail issue. Okay, when you say there is there is positive relationship between A and B, or there is negative relationship between A and B, you are using one tail hypothesis, and that's what they call directional hypothesis. In that case, you show the direction that you want. I want the direction to be significant. So it's clearly that we want it significant. Any other things is not supported. So that one is one tail. But by the time you said there is significant relationship between A and B, you keep mute, meaning that you didn't tell us what direction you want. In that case, you ask for to tell because you don't specify any direction. Okay, I don't know, maybe some of you might have this kind of hypothesis. And I have seen somebody that do a kind of maneuver because he look at his hypothesis. Some of them are negative, and he hypothesized in his there that hypothesis, all of them positive, positive, positive. But he unfortunately discovered after doing analysis that all some of his relationships are negative. So he quickly went back to his hypothesis and changed them to two-tail. Yeah, so you see, this is how the maneuver is being done, something like that. And it was accepted. And even his supervisor recommend him that he should go and do that. Because if he didn't do that, he will have a lot to say in his
to explain. Okay, so sir, in a model that has a combination of two types of hypotheses, maybe some are directional, some are just a two-tail like this. If you come to run this bootstrapping, are you going to run it twice for the one tail and then for the two tail?
I don't see any such kind hypothesis that says you have both one tail and two tail.
Yeah, what I mean,
we don't have it.
Yeah, what I mean, for example, there are some certain relationships that are established to be negative. For example, relationship between rigs and maybe a certain behavior, it's mostly negative. So if you hypothesize there will be significant negative relationship between certain rigs and this, and maybe you have another relationship with some another variable which maybe is non-directional. You just mentioned there is a relationship between it. Is that possible?
No, please don't do it in the model. In one model, don't do it.
Yeah, that is what I'm saying.
Yeah, don't do it in one model. Your model should either be directional or non-directional.
Or non-directional, okay.
Yeah, it should be something like that. Because maybe, I am not sure because I don't have all the knowledge. Maybe there are some that if it happened that you have it, if we can have it anyway, maybe you have to run it in 2 times. I'm not sure anyway. Yes, I'm not sure. Yes, yeah. So this is where you talk about the one tail, two tail issue. But let me add that when you have, there are 3 constructs that you should have, and you should know when to use one tail or when to use two tail. If you have IV to DV, it's always, it should be one tail. One tail or two tail, sorry.
Yeah.
If you have moderator, one tail. But if you are testing mediation hypothesis, it must be two tail.
Two tail, okay.
Yes, okay, remember, direct relationship, one tail or two tail. Mediation, two tail. Moderation,
one tail.
Yes,
okay.
That is how you do it. Okay. In this case, we want to know, we hypothesize that, okay, let's go back to our model before let's close this one. In this case, we hypothesize that there is positive relationship between all these, okay? Security is positively related to use. Trust is positively related to use. Authentication is positively related to use. Privacy also is positively related to use. In this case, we use one tail. Okay. So in that case, how we do it? We just run and say bootstrapping, then we click one tail, and here test for significance level is we leave it as 0.05. That is at 5% significance level. You just leave it like this. In this case, we don't change anything because yeah, we leave it intact. That's how we want it. If you want to change, you can change to satisfy your needs. Then we start calculation. So, okay, you can now differentiate between bootstrapping and the PLS algorithm by just look at how slow it is. If you are running bootstrapping, it will be very slow. If you are running PLS algorithm, it will go as quick as possible. Why? Because in bootstrapping, you are resampling. So that's why it takes time. I could remember I analyzed one data back in 2017. Yes, one of my friend data was analyzed. I analyzed it anyway. Unfortunately, he has moderator and he has higher order. So he has a lot of items and he wants only one moderation. We tried to test that moderation, but believe you me, when we run the moderation, we want to get the result, we could not get the result until the following day. He just took the laptop, he went back home, he put it and sleep. In the morning, he saw the result. So meaning that the more items you have, the more slow, the slower it should be when you are calculating or bootstrapping. So we, according to our model, we already bootstrap. So we want to know whether our hypothesis is accepted or not accepted. We want to see the level of significance of our prediction. Is security really predicting use? We hypothesize that if a customer of mobile banking perceive that this mobile banking application is highly secured, we expect that person to use that software. But if he perceives that is not secured, then it shouldn't be significant. He should not use the software. We expect also that trust, if you have a trust, you give it trust, you will use that software. And we also hypothesize that if there's a lot of authentication before entering into the platform where you will transfer money, view your account statement, account history, everything, if there is very good authentication, you will use that software. Maybe, for example, if you don't see any authentication, by the time you just open it, you will just see your account. People will be scared that somebody might compromise their account. So therefore, we expect authentication to also be significant. Then we talk about privacy. If the more privacy this software has, the more people will want to use that kind of software. Because if you don't have privacy, everybody, every Jack and Harry can see the amount of money you have in your account. Then you just have to abandon it. You will not use it. So that is what we hypothesize in this model. So we want to see, is it significant or is not significant? In that case, we look at the T value. What you see here is no longer beta value, is no longer part coefficient, is now significant of beta value, is now significant of part coefficient. And we call it T statistics or T values. Do we understand? Yes.
Yes.
Okay, so the next is we look at them. How many are significant and how many are not significant? I want to hear from you. Anybody has idea? How many are significant? How many are not significant?
3 are significant. while one is not.
Why?
Security, trust, and authentication are all above 1.64, while privacy is less than 1.6 and 1.5, which is not significant.
That's correct. What I'm saying is that we say, okay, maybe okay, maybe let me share it first. You see it, maybe okay. This one. Let's go back to this table. Let's look at one tail. At one tail, okay, pardon. At one tail, t value must be greater than 1.64 for it to be significant. If you have hypothesis that says there is a relationship between A and B, we expect your t value to be greater than 1.65, 1.645. If it is less than 1.65, meaning that it's not significant at 5%. But when we have two-tail hypothesis, significant start at 1.96. The reason why I didn't talk about 10% is that, let me just delete it because it's no longer reported. Okay, let me just do away with it for now. Let me just do away with it. Maybe it should not be part of it. Okay, so we don't need it any longer because it's not being used. Okay, just save it and open it again. Okay, so at one tail, we should have 1.64 at the t values for it to be significant at 5% p value. Okay, then for it to also be significant at 1%, one tail hypothesis must have a value of 1.96. But if you have two tail, to get t value of must be greater than 2.575 to be significant at one tail. This is how you interpret t values. So we go back to our model and see. When we see security to use is greater than 1.64, so significant. Trust to use is greater than 1.64, therefore significant. Authentication is greater than 1.64, therefore significant. But privacy is less than 1.64. So therefore, we conclude that this one is not significant. And by the way, if you remember, privacy to use is negative. If you remember, it's negative. So that negative also gives us impression that even if it is significant, it's not supported. Because we don't hypothesize it that way. We don't say we hypothesize it's negative, that there's negative relationship. So whether it's significant or not significant, from the onset, from part coefficient or beta value, we have already understood that that one is not supported. So this is how you talk about the part coefficient. T values. And this is how you know whether your hypothesis is significant or is not significant. This we are talking about direct hypothesis. Maybe in the future we'll talk about the other indirect or moderate hypothesis.
Victor, if privacy is not significant, why there is sign of positive on it?
No positive here. Also, let me, when you are in t value, no positive, no negative. They are all positive. T value, all positive. Is when you have in part coefficient, that's where you have positive or negative. Let's run the part coefficient and see again. You run PLS algorithm and you see this one is minus 0.099. So it's negative. But when you run t value, you don't expect to see the negative. just expect to see the level of significance.
No, I mean there is a positive sign on privacy construct
Where is the positive sign?
on the construct of privacy here in the model.
Here,
Yeah.
no, where is the positive? No positive here. Here is negative. Okay, maybe
No,
I
no, on the left, yes, here.
what?
On the construct itself, yes, here, yeah.
No, no, no. Okay, so let me, okay, please forget that one. I will explain that to you. What it means here, when all the construct has positive inside, what is telling you that there are items inside the construct. You understand? Maybe if I bring out a show the indicator, you see there is that item is not that one is no longer there. Show when we show you the positive is removed.
Ah, okay, okay.
Do you understand? Forget that positive.
Yeah,
That
yeah.
positive is telling you that something is hidden inside.
Okay, okay.
That is it. Yes, inshallah. Okay. All right. So let me just click it and say we go back and we look at it. Maybe it could be a wait and see. Okay. So please just understand this one. Look at these numbers. Security has 0.959. This we run first run. Okay. Okay, please take it at the back of your mind. Okay, all right, it's somewhere. 2.959. We want to run again. We want to run the bootstrapping again. We run bootstrapping again. Boom. Now it's 3.237. Why?
Yeah.
Huh? Before we have 2.29.
2.59 something before.
Yeah, 2.5 before. Now is 3.
Because of the iterations.
Because of the
Iterations.
Yeah,
see, okay. The reason is that we are bootstrapping. So when we bootstrap, we are resampling. When you are resampling, meaning that the computer is taking different items at different points. Meaning that, for example, now if you have 10 items, okay, you have this as your items, and this one, okay, let me see. Let me show. Okay, so this one has 5. Okay, let me show this one. Okay, so there are 5 items here. If the software want to run bootstrapping, the first thing it does, it's now look at resampling. It will take 1, 3, 5. Okay, maybe the next time you run, it will not take 1 or 3 and 5. It will start with 2, 1, 4, 2, 3. And that is why you see variation in terms of the beta and t values. It's not always taking you. It's not always taking the same pattern, the same when resampling. It takes different pattern, and that is why the level of significance or the level of t values changes. That is why.
Hello, sir. Can it ever change the non-significant to significant? Because privacy remains non-significant. Yeah,
see, sometimes there's what they call okay, I don't know how to put it in English. We call it the Kalesha. I escaped, but in a very top position. I got top time before I escaped. So that is what it means. You escape, very narrow escape. I think yes, something like that. The narrow is narrowly going up. So sometimes if you continue running, sometimes you may see this one to be significant.
That's what I want to
You understand, but it will not be significant to that level. That is why t-value, p-value alone is not enough to judge a hypothesis. That is why they introduce confidence interval. Okay, that's why they introduce f square. You have to test all of them before you now say hypothesis is supported. And there are a lot of papers that a lot of donors that if you send your paper just by reporting only t-value and p-value, they will not accept it because you can get significant by doing again and again and again.
Okay, repeated.
Yeah, if you repeat, sometimes maybe you can say, okay, bootstrapping, sometimes it will give you even up to 0.7. You understand? You now say insignificant, but when you go and check the other one, you find out that you see it's going down. You understand? So that is the effect of resampling. Don't get panic when you see your hypothesis supported and later not supported. You just have to admit that it's not supported. Just try and know what to tell them. Why is it not supported or why it is supported? And ladies and gentlemen, up to this point, are you clear?
Yes, sir. Very clear.
Dr. Mesoon. Okay. Ramash. All mute. Muhammad Shakir, any idea? Hope there is no problem.
I'm okay.
Ahmad Shukri.
Okay, doctor. Okay.
Okay. Omar, Dr. Omar, are you okay? Okay.
Inshallah, inshallah.
Oh, no problem. What of Dr. Aznida? Aznida, are you still following us? Maybe even if you don't follow.
Yes, yes, I'm still here. Yeah, I'm following and trying to recall, recall back.
Yeah, you better do because you will need to write a lot of papers, right?
Oh yes, correct. Same advice to all other friends too.
Yeah, that is okay. What of Amin? Dr. Amin, I don't know if you are with us. You are not with us. Yes, thank you. Okay. All right. So up to this point, this is how you get the significance and weight. No. Part coefficient and significance of part coefficient. Now we talk about part coefficient, that is beta value. Now and then after we run bootstrapping, we get the t value, and we check whether our hypothesis is supported or is not supported. I told you you don't rely only on t value to tell your reader that you have successfully established a strong relationship between your construct, unless you check for the confidence interval. And the confidence interval, how is it going? How are you going to read the confidence interval? This is how. You will not see the confidence interval here. If you want to see the confidence interval, maybe you have to go to report. Okay, this is what you have. You can only see it here, but if you want to see the confidence interval, maybe you can have it here. No, you don't have. You cannot. You just have to go to. You just have to go to part coefficient report. Sorry, you check the report. In the report, this is your relationship. You have original sample. When you see original sample, it means beta values. So this sample means you don't need it. This standard deviation, if you are reporting, you report standard deviation. T statistics is your T values. So what means is that what is here should correspond to what is here. 3092 for security. You should have 3092 is here. 1.494 privacy, 1.494 privacy. Do you see it?
Yes.
Yeah, so this is this is it. Then the fee value here is telling you that the level of significance. Okay, is this one is greater than, it should be greater than, if you remember, we said in the p value, it should be greater than 2.575 for it to be significant at 1%. So in this case, we have, it's not up to 2.5. So it's still significant at 5%.
5%.
Okay. The third one, security, is significant at 1% because it's greater than what? 2.5.
2.5.
Also, this one is also greater than 2.5. That's why it's significant at
1%.
1%. But now, we cannot rely only on this. We have to go and check the confidence interval. The confidence interval in here, you go for confidence interval bias corrected, this one. Okay, so now confidence interval bias corrected, what it's talking about is that you look at 5% and 95% confidence interval. You look at it and say, is there any sign, different sign, plus, plus, negative, negative, plus, plus, negative, negative. Okay, or there should be, that's how they said is, there shouldn't be any zero in between. For it to be significant, if you look at it, upper level confidence interval should not contain zero, or it should be positive, positive, negative, negative to be significant. If positive, positive, significant. If negative, negative, significant, depending on how you hypothesize. But if 90% confidence interval contains zero, then it's still not supported. So in this case, when we look at this one, 5%, this one positive, positive. Security, positive, positive. Trust, positive, positive. It's already that. So we just forget privacy because it's already not significant. For instance, we don't care about whether it is the bias correction is okay or not. So this is how you explain confidence interval. There is no zero in between, meaning that all the figure, all the values of 5% and 95% should not have a conflicting sign. Positive, negative, negative, positive, not significant. It should either be positive, positive, negative, 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 depending on how you hypothesize. Ladies and gentlemen, do you understand this simple arithmetic?
Yes.
That is great. Please, do you have any question? Okay, if you don't have any question, we move to the next item in the structural model agenda. We finish only 2 now. We have 4 to go. Do we have any question, please?
Not from here.
Okay, let me check the chat box. What's the difference? No. We will come to that. Okay. Yeah. You advised me. Very good. Okay, nobody said anything. Okay. All right. So then we move to the third stage. And the third item is R squared. When you finish evaluating the collinearity, you find out that there is no collinearity, between the items, among the items, or among the construct. Then the next you examine the size and significance of part coefficient, and that's what we just finished. Sorry. The next we examine the R square. R square is called in-sample prediction. We are talking about, we want to predict how our model, how our items, how our construct are predicting our construct. When I say, I mean how our exogenous construct are predicting our endogenous construct. At what amount? Okay, at what amount can we say this construct explain that particular endogenous variable? This is what is called R square.
Okay.
Yes. You have.
Okay. Can I mean, can you adjust your camera? I think I cannot see your face.
Please, I cannot hear you.
I cannot see your face.
Eh?
No, I cannot see your face. Is it possible for you to adjust your camera? Maybe?
You cannot see what?
Your face.
I'm not hearing you now.
You cannot see my face?
What do you need this face for?
Only half.
How? Oh, okay. Wait. Let me stop sharing. Now.
So Salisu, you must always adjust your screen.
Okay. So maybe the screen that is not well adjusted.
Yeah.
But it doesn't matter. There's
It doesn't matter. Thank you, doctor.
You know, I attended one workshop from start to finish. I don't know. I don't even know who. I didn't know who is the person in charge. We just went for him. How he said, finish and go. I only know his name. This is the name, but I didn't know who is he. So maybe I
am more confident when I can see your face and explain.
The visual of the coach motivate, really increase motivation.
Thank you, doctor.
Okay, no issue, inshallah. Okay. Okay, so okay, let me just try and see if you can see me well. Okay, all right. So I say we can go back and see. We finished 2. We are going to 3, and the 3 I said is R square, and I told you that R square is talking about the contribution of all your IVs toward predicting the DV. What the level of their contribution. The contribution is from 0 to 100%. Okay, meaning that from 0 to 1. We want to see what is their ability to predict that construct. That is what it's talking about, the R square. Okay, so how are we going to see whether our the level of R square is? This is how. You go here, you run PLS algorithm. This is PLS algorithm. You now say start calculation. When you finish calculation, you come to the right side where indicator calculation result, left side, I beg your pardon. Then you look down, you see where
screen not shared, sir.
Yeah?
Not sharing, you know.
Screen not shared. Your screen is not shared.
Yeah,
sorry.
Yeah, because you wanted to see me. That's why that's why I just said.
Yeah.
Sorry, doctor. Sorry, I disturbed.
Okay, so let me share screen. Okay. Okay, now you can see, right? Yes, clearly. Okay, so now this is what we want to see. We want to see the level of how the total variance explained by these four constructs. Okay, what percent does these four constructs contribute toward explaining the use?
Use.
That is what is called R squared. In this case, I told you, if you want to know, the first thing that you do is, okay, somebody you want to, okay, the first thing that you do is you go to calculate, you now say PLS algorithm, you start calculation, then you go to the left side of your laptop or computer and you look at the report. Wherever you see report is only one there, just click it. Or if before you can do that, if you want, you can go to go down and see that's why you see construct. So in the in front of that construct, there's what they call there's one bar. You click the bar, the down arrow, you will see R square there. Then you click R square. Okay, I am saying two things. The first one, you go to report, you can see R square here. The second one, if you don't want to go to report, you can see it from the model. You can go down to construct. You click here, click the construct. You will see the R square. You click the R square. I hope you understand. But the question is, when you click the R square, you look at the model. You find out that all the numbers in the construct have disappeared. It remains only one unused. Why?
Yeah, because the R square unused is the total contribution of the whole four independent variables in the model, right?
The IVs explain or contribute 32.9% of the prediction of use.
That is, yeah, that's correct. What it means is that we want to know the total contribution of all this. We now get the R square. This R square is 0.329. That means it's almost 0.33, right? Because if you approximate, it will be 0.33. This number inside this use is called R square. Depending on what you put here, you come to construct, you say R square, you click R square, then this one will come. And because you don't have any construct attached to security, that is why you will not see R square here. Because R square is the contribution of construct to another construct. Do you understand? So in this case, yes, you will have 0.329 as our R square. But is this enough? That is another question. So there are a lot of literature that says that give us threshold of this R square. Maybe we can go back and talk about it here. You can see we finish this one, and we move to R square. This is R square. Okay. Okay, we can now say R square is a measure of model level of predictive accuracy. How accurate your model is. R square represents the endogenous variable combined effect on the endogenous variable. This one is already explained. This effect ranges from 0 to 1, with 1 representing complete predictive accuracy. Do you understand? But you should note that in a reflective model, don't expect R squared to be great to exactly 1, because it's just not possible. What you are saying is that if it is 1.00, what it's telling you is that no other construct can be attached to that dB again. Do you understand? So it should be between 0 to 1. So there are a lot of rule of thumbs that say some say it should be less greater than 0.1, some say greater than 0.2. But according to here, 2011, he said, if your R square, that R square we show this one, if this R square is 0.75 and above, we consider it as substantial.
Substantial.
But if it's 0.5 and above,
Below.
it's moderate. But
Below.
no, not below.
Below. 5.55 will be substantial.
No.
0.5
is 0.75 and above.
Okay.
Is substantial. 0.5 and above is moderate. 0.25 and above and okay, below 0.5, sorry, is weak. Oh yeah. You are right. 0.75 is substantial. When you have R square 0.75 and above, you have R square substantial. You understand? Okay, let's start from the weak. Maybe you will understand better. If you have R square less than 0.25 to 0.25 is weak. From 0 to 0.25 is weak. Okay, when you have above 0.25 to 0.49 is still what? Moderate.
Still weak in that case.
No.
Is it moderate?
Okay. See, understand this way. You have 0.75. That means 75%. When you have 75%, just take it this way. If you have 75% and above, substantial. If you have 50% and above, moderate. If you have less than 0.25 or less than 25%, is weak. Do you understand?
So yes, if you have 0.4,
0.4, yeah,
it's moderate.
It's moderate. It's moderate. It's just like between
so it's
this
only
to this.
It's only below 0.25 that is weak.
Yes,
weak.
It's weak.
Okay. Okay.
Yeah.
Okay.
So please, do you understand this one? We are moving to another one.
Understood, sir.
Okay, that is great. The next is the next on the line is we finish R square. The next we go for effect size, that is F square. When we say
and sorry, sir, there was something you didn't clarify. Difference of the two types of R squares, the adjusted and the normal R square.
No, please just forget the adjusted. Just concentrate on the main, the first one.
The main R square.
Yeah, don't report the adjusted R square.
Okay.
Just go for the only one R square, not adjusted R square. Okay, so maybe we can demonstrate it there. You will see something like this. This is R square. When you go to report, you will see this is, look at R square down here. A quality criterion, R square. Then look at R square. There are two types R square here. R square and adjusted R square. But I suggest don't go for this adjusted R square. Just report just R square. That's how I was advised by one PLS guru when I was doing my paper. Is that okay? This one, okay, yeah. So the next is
effect size.
Effect size. Effect size, we are talking about the contribution of each one. Yeah, before R square, we are talking the contribution, the composite contribution, the total contribution of all your IVs. Now we want to see the contribution, individual contribution, contribution of each one. All right, this is how. Now we run the PLS algorithm, go to start, click the start, then you go to report. When you go to report, go to F square. Okay, F square is down after R square, F square, then click it. This is where you will see the F square. The F square tells you the contribution of individual IV to the R square or to DV in particular. You understand? So this is how you, can I, please wait. Okay, in this case, we have authentication 0.075, privacy 0.111, security 0.063, trust, privacy 0.011, sorry, security 0.063, trust 0.059. But what of use?
That's the DV.
That the DV, that is the endogenous variable. So you don't expect to have F square on it. You don't expect to do that. So this is how you look at it. How do you interpret this? Now, according to a lot of people, for example, there's Cohen. This is the rule of thumb. Rule of thumb is that if greater than 0.02 is small. If
Small.
From if it from 0.02 and above is considered small. 0.15 and above is considered minimum. 0.35 is considered large. So, and how this we don't want to go to extreme in the sense that we don't want to go to tell you how it's being calculated, because all what we are doing, they have a formula for their calculation. And if we now say we have to tell you R square included, R square excluded, minus R square, all these, we already have it in the software. So all you need to do, just click and click. Forget the calculation. They have all done it for you. Do you
in the previous version, you have to do this calculation yourself.
So we are no longer in that age.
Hey, God, good. Jesus Christ.
Yeah, so we are no longer there. We have moved further. So you don't need that. You just test, click, then you get it. So in this case, you just look at this one. So now we want to see, we have this authentication is 0.075. It's considered what?
Small.
It's considered small. Why?
Because it's greater than 0.02.
Yes, it's greater than 0.02, but it's not up to 0.15, right?
1.5, yes.
Something like that. So, but this privacy is
no effect.
It has no effect.
No
You
effect.
see, that so, and that is the reason why a lot of people are saying you should, if in addition to reporting the T value, phi value, confidence interval, you also put F square as one of the parameter to assess the level of significance. You understand? If you you have to satisfy all the four: one, T value; two, phi value; three, confidence interval; four, F square. There are a lot of people that are saying that you have to be using it. There's one paper I wrote. I have to use all of them. I have to put it in order that to satisfy the reviewer that is significant. Because he didn't say, he said, okay, you have all of them are significant. I see, because you show me the the t-value, the p-value, and the confidence interval. But I want to see the effect size. Is the effect size okay? Luckily it was all okay. They were all okay. But if it's not okay, you just have to tell them that that one is not significant. It's crazy, Allah. Okay. Okay. So this is a p value. No. F square. Then the
F
next
square.
is we move to the next is not on the line after F square is predictive relevance. Predictive relevance. Predictive relevance is
Sir.
called Q
Sir.
square.
Excuse me, sir.
Yes.
Should we report F square in formative measurement?
See, yes.
Is it same or there is difference between formative and reflective for the R square and F square?
We are not talking about here. We are not talking about the measurement model. Okay, we are.
But I'm talking about the construct.
Yeah, we are talking about construct to construct.
Yes.
We are talking about the level of significance. So F square, you reported whether you have formative or reflective.
Formative or reflective.
Yes.
Okay, sir. Thank you so much, sir.
Yeah, no problem. Okay, so the effect size, we finish this one. We go for predictive relevance. We want to see whether our prediction is relevant. So meaning that we go for Q square. Okay, how do we assess the Q square? The predictive level relevance is, this is how we go to calculate. We go to blind folding. Okay. Please, can I? Wait. Okay, please, I'm coming. Please, give me 1 minute. I'm sorry. And then just okay. Okay, so sorry for the interruption. Okay, I check something. Okay, so next is we said predictive relevance. We go to calculate blind folding. Calculate blind folding.
No, that's you pick bootstrapping. No.
No. Yeah. Okay, yeah. I will go back. Calculate blind folding. You see? Let me do it again. You go to calculate blind folding, then okay.
Omission distance.
Yeah, the basic setting, you look at the omission distance. You sometime, okay, let me see.
5 to 12.
Yeah, see, if you click, you can leave it. Omission distance can be when you click, you see red. Don't use it because it cannot be used. You can only use omission distance that is okay. That is in this color. You understand? You omission distance always by default is 7. You just leave it 7, please. Okay, if you understand more about this omission distance, maybe you can read the basic setting omission distance, what it is and how it is. But by default, it's 7, just leave it 7. Unless if it is red, then you move to maybe 8. Do you understand? Okay. So the next is when maybe that is okay, I beg your pardon. You say calculate blindfolding start calculation, because the omission distance is also active. So I just move. So okay. So now how do we know? We go to report, then you look at this construct cross validation redundancy. In this case, we want to see if this q square is greater than 0. Okay, if it's greater than 0, means that we conclude the model has predictive relevance. In this case, we look at our own under use. Q square is 1.1580, 0.1580, sorry, 0.158. We consider it as okay because it's greater than 0. They say it should be greater than 0. So that one is greater than 0. That's why we consider it as, we now conclude or write that our model has predictive relevance.
Okay, sir.
Yes. Okay. The next is we test for which one?
PLS.
Yeah. Okay. PLS predict. Okay. So okay, let's go to the. You will see this is when. Okay. So we finished the Q square. They say it assesses the inner model's prediction relevance. Q square greater than 0 for particular endogenous construct. The path indicate that the path model predictive relevance for this particular construct is okay. Then we can assess it using blindfolding. This is all we've done. We've done that already. So we've done that already. So that's it. So, but recently, some people came out with a challenge. They challenge the Q square. They say, if you want to really get the predictive relevance of a model, you need to measure the out of sample. You need to measure to do out of sample prediction. Out of sample prediction. In this case, they say blindfolding is not omitting the entire data set. Is not omitting. They are predicting the data set within data set. They are not predicting the data set on another data set. You understand? That is why they say it's not out of sample measurement prediction. They need to find out another parameter that will measure the out of sample. In this case, they come out with what is called PLS predict. That PLS predict is they are splitting the data into different samples. So they use one data to predict another data. That is out of sample prediction in a nutshell anyway. So there's a lot of paper that talk about this one. The most recent paper is this one, predictive model assessment in PLS guideline using guidelines for using PLS predict. There is another one. The first one was elephant in the room, the predictive performance of PLS model, which was written in back 2017 or so. Okay, then there is another one, assessing the predictive performance of social equation modeling. Also, these three papers I will give you a guide. I will give you these papers. You see how really how this PLS predict works. And this PLS predict is also one of the best way of predicting your the relevance of your model. So in this case, it's very good if you can include it into your paper, because sometimes you don't include new things in thesis, because it will create a lot of questions and confusions. You will end up cannot satisfy your supervisors or your reviewer. In that case, I suggest, except if you are asked to report it, you report. But if you're not asked, I suggest don't report, except also if you can depend it well there and to their satisfaction anyway, then it's okay, because it's a new thing. You know, sometimes if new things come out, people will tend to disagree with it until when it becomes a norm.
Okay, so you're suggesting for thesis report we can stop at the predictive relevance.
Predictive relevance,
but,
that is.
Yeah, but for paper we can include PLS predict if we.
Yeah, for good paper. Let me say it this way: for good paper.
For good paper, yes. Okay.
Yeah. For good journals, for if you want to send the Q1, Q2, Q3, or ISI,
then you have
so
to include
please
all the news.
Include this one. Will give you edge.
Okay.
Yeah, but if you are doing PhD
thesis
and if you are doing thesis and you know where, for example, if you are doing it in UUM, for example, I don't think you need to do it. You understand?
Okay.
But if you are doing it in USM or USM in particular, get ready to do that, because there are a lot of people that
programmer is there.
He brainwash everybody there.
Yes, really, I'm seeing it. I'm not there, but I'm seeing it.
So exactly. If anything new comes in, if you are in USM, get ready and adapt.
You have to.
Yeah, know it and apply.
Okay.
Yeah, something like that, inshallah. Okay, so so how are we going to do this PLS predict? Okay, ladies and gentlemen, this is how. It's just all simple things. Unless if you want to know more difficult things, you can go for it. Just we have this model. We just say calculate. Now come down and see there's PLS predict. Just click and click and click. Simple as it is. Okay, now we are clicking PLS predict. Now, by default, this basic setting, leave it as K10, number of fold are 10 and number of also repetition are 10. Don't change anything, leave it like that, okay? Then you start calculation. Now start calculation. So this one may take time because it's predicting when it's a K10, meaning that your sample is divided into 10. So now they use the one that is they call it a training sample to predict the okay. Let me, if I remember, I'll tell you this one. Use training sample. Okay, I will tell you this one. Okay, sorry. Okay, in this case, this is how it is. You run already, but you've not seen anything here. All this is not, we don't see anything here. We run PLS predict. Now we see, we want to see something. If we run like R square, okay, we want to run, we start running, we finish, we want to see something like R square or like ABE or like beta value, or so we want to see value there, but it's not there. You see, nothing is here. Only our model, as if nothing happened. So the thing that you do is come to here, don't say it's not done, it's done. Come to report, click report, and this is where you will see your PLS predict, and this is where you will talk about the PLS predict, and this is where you decide whether your model has a very good prediction ability or it doesn't have. This is why you check. And how are you going to do that? This is how. Let me go back to this. Okay, let me just open this one. It's just this one is an example. I copied it from one of my paper I sent for review. It's in a Q1 and it's under review. Okay, this ECS 1 to 8 are my items for my target construct. That is my DV. Okay, so when I run the model, it will give me two thresholds. Number one is called PLS, the other one is called LM. Okay, it will give me measurement prediction errors. There are 3 prediction errors. Number one, they call it RMSE, MAE, and MAPE. A lot of people I don't report MAPE. That's why I didn't put it here. I only put 2 RMSE and ME. Okay, so this is it. This is the table how you report it. But in here, you look at there is PLS here and LM as you see in the table. PLS, LM. What we want to see is we want to see LM always should be greater than PLS. Okay, or in another way, PLS should be less than LM. Do you understand? We look at here, we look at use, for example, use 1, 2, 3, 4, 5. These are the use. We want to see whether PLS is less than LM. If PLS is less than LM, meaning that we now conclude that we have a very good prediction ability. Is that okay? PLS should be less than LM. Okay, now we to show you how we can do it to see whether it's greater or is less than, we can copy this one and take it to Excel. Maybe you will understand it more a clear way. So this is I put it here. Okay, so in this case, this is this is for LM. I click LM, I copy. I will click PLS also.
Sir.
Yes.
Excuse me, sir. Of PLS greater than LM, what we can do in this case?
No, see, just wait and see. I will tell you what can you do, what you can do. Okay.
Okay. Sorry.
Yeah, you just tell them that this is what you have. Okay. Okay. So this is PLS. This we copy LM already. This is LM. Okay, let's write LM here. LM. This is PLS. Then we now put this one. This is PLS. So what we want is the value of here should be greater than the value of here. Okay, the first thing that we check to confirm, we have to look at the Q square here. Is Q square greater than 0? Yes. Then the next you assess this RMC and MAE. Okay, this is how you put it. Now we take this one. Okay, let's put all of them here and put them, give them the full numbers. Okay, into 3 decimal places. All of them 3 decimal places. All of them 3 decimal places. Okay. Okay. So now we want to. This is LM. Okay. Ramsey LM. Okay, we can remove this one and put it back. Okay, and now we subtract this one from this one. Okay. Now, okay, we take this one. Okay, copy. We put it here. We copy this one. We put it here. Okay. Now we subtract this one from this one. Something like this. Okay, let me go back to the slide. You see something like this. Maybe you understand it better. Okay, so this is a PLS, just like the one we did. We copy, this is for the PLS, and this is for the LM. Then we subtract the value of all the errors, that is RMC, ME, and predict. We subtract it, we subtract LM from it. That is, we say PLS minus LM. So we look at it one by one. There is certain criteria we follow to say if it's okay or it's not okay. If they all have, if PLS minus LM, if they are all negative, that is, if RMSE are all negative, that is how we call it. If they are all positive, that is how we call it. If some of them are all positive, some of them are negative, that is how we can call it. I beg your pardon. And this is how. This is, you follow this diagram. According to this diagram, the first thing that we do is we compare the value of these prediction errors, RMSE, MEA, from the PLS analysis with LM. We compare the value of each indicator. When we compare, the next is we ask ourselves, are all the PLS values greater than the LM? Less than the LM. If all of them are less than the LM, then we now conclude that the model has high predictive power. Let me say it again. If all the errors, that is RMSE, MEA, and MAPE, are all, the PLS are less than the LM. When you calculate all the figures in PLS are less than the figure in LM, then we conclude that the model has a very high, predictive power. But if no, then we look at it this way, that half of them, half of the PLS are less than the LM, while half of them are more than the LM. Or most of them, that is, or 70% of them are greater, PLS are greater than LM, the value of PLS are greater than LM, then we now consider, we now say the model has medium power and predictive power. But if no, again, meaning that if none of them, all the PLS values are greater than the LM values, then we now say, if yes, we now say the model lacks predictive power. But if very few, like 1 or 2 out of 7, now we now say the model has low predictive power. In this case, when we look at this, okay, let me go back. Okay, when we look at this one, what can we conclude that? We conclude that all the PLS prediction errors are less than LM. So therefore, we conclude that our model of this example has high predictive power. Maybe we try using our own data, this one. So we have the PLS, RMSE, okay. So I told you MAPE is not being used. A lot of people are criticizing it, so we remove it. We go for only these two. only this one and this one. If you want to know more about it, maybe I'll give you the paper that you should use and to understand it better. Okay, we are taking this one, we put it here. Okay, this one. Okay, wait, I beg your pardon. This we start with PLS first, then we put LM to it. Okay, this one is PLS. Okay, the other one is LM. So now we want to see okay, we want to see now this one. Okay, if we want, we can now see PLS minus LM. LM. So now, okay, this one, yeah. So now we now see, we now say this one, this is the PLS, this one equals to, maybe we can say equals to, and this one minus RMC of this one. And what it gives us, it gives us 0.02. Then we can say, if we want to do the remaining, we can just double click and it gives us all the result. This one is RMSE. Okay.
Yeah.
The next is we take this one. Now we say equals to this one minus this one. Then we say okay. Then we bring all of them down here, something like that. Okay. Then we go for Q predict. Now we now say equals to what is it? Equals to this one
F6
minus this one. We say okay equals to. Then we bring all this down. Okay. So now this is our PLS result. This is what we want to see. Ramsey, this one is MEE. This one is
Q predict.
Q square. So, but see, what we want to see is these two. These are our concern, our concern. And a lot of people are even criticizing this one, that maybe we use it's better if you use RMSE. You read about it. I will give you the paper. You read about it. You will see what it means, and why not MEY RMSE. Okay. So in this case, we look at the.
So we have now some figures in positive and some other figures negative.
Thank you very much. So now here, what you should do is you look at this table, this figure. Where did our result fall?
Medium.
Where did it fall?
Medium.
Eh?
Medium.
Are you sure?
Yes, let's go back. We have three positive and 2 negatives. Let's go back to check the result. We have 3 positive and 2 negatives.
Okay, so maybe they say most of them. This one, most of them are exactly half or more than half of them are not have negative value. Then it's not significant. We consider it as what? A medium. But here it's not. It's less than half. Right?
It's 60-40 here.
Yeah. So 60-40, the meaning that is what? Eh?
Yeah, the teacher want to learn.
No. See, that's meaning that is we now go for it has low predictive power.
No.
Yeah. See, we don't have the same or most of them. Do you understand? We don't have most of them. See, only 2 of them are satisfied. Okay, so meaning that not most of them. They say either most of them or half of them. Look at what look at the diagram. Look at the diagram. He said, most all the same number of PLS value less than LM values? Do you understand, sir?
Less than. Okay,
Yeah.
less than.
So if it's less than, it should show negative. So we only have two negatives, for example. So in this case, we conclude that our model, some of them they have, but very few of them, at least two out of 4 is not much, is not half. So out of 6, sorry. So in this case, we now say we have low predictive power. But in case none of them has in case none of them, for example, all of them here are positive, for example. Now, what do we conclude? Then we conclude that our model doesn't have predictive power. No, at all. It's only when all of them are negative here, when we subtract, when if all become negative, meaning that we have high predictive power. But if half or more than half of them have negative, we now say they have medium. But if very few of them have negative, we now consider it as low. But if none of them, we consider it as none. That's how we just report it. I don't know if you understand it. Hello, ladies and gentlemen. Are we together?
We are together.
No. I'm saying, if I'm saying, I don't mean, are you still on the seat? Are we together?
Yeah, we are with you.
You know what?
We are managing our confusion.
Yeah, this
Dr.
is
Salih, such things, it doesn't to be understood. Maybe it's easy, piece of cake for you. But for no, not why. These things needs practice, and it will not be understood or even comprehended by you by a day and night.
No.
It needs practice.
Wait. Let me just give you one simple advice. If you want to that is why I said, if you come to study to a workshop like this, please can you if you
Nasi banyak.
Okay, if you my advice is that if you are coming for if you want to learn PLS well, you just have to admit that you want to attend more workshops. Okay, let me tell you how many workshops I attended. I attended more than 50 workshops. I don't know how many times I attended Ramaya's on in USM. Here in UM, he came, I follow him. And I don't know how many times I attended a lot of workshops of other people. And that is how I get to understand it. And if you want to do that, please try and attend more. And let me give you one simple advice. If you want to really learn this kind of things, try and go to somebody that understands it exactly from somebody, not from YouTube. Don't just see somebody knows it in YouTube and he teach you. Please, there's a lot of things that he doesn't know, because YouTube is one way. You cannot answer. He cannot answer you. You just see what you see. In this case, I advise, if you want to learn, go to somebody that learned from somebody. When I say learn from somebody that really learn it on the surface, from somebody like me, for example. Okay, let me talk about Ramaya. Ramaya, he didn't learn this through only reading books or through YouTube or through any other channel. What he's doing is that if I tell you now, maybe Ramaya is in Germany meeting here or meeting such start omitting wrinkle just to know more about PLS. You will maybe agree with me. I don't know whether he's there or not, but what I'm telling you is that Jeremiah, he knows PLS and he is one of the best PLS user in the whole world. Let me say it this way, but he goes out to people that has knowledge that he doesn't have to learn. He didn't sit down in his room only watching YouTube every time you're watching YouTube and learn. Or maybe somebody that is watching YouTube will teach him how to do it. Why don't you then watch the YouTube yourself? So what I'm saying is that I suggest whenever you want to attend a workshop, try to attend to somebody that is not YouTuber, somebody that really understand it from a good source. I think this is very good advice anyway. I don't know if you can do that. So please, I want you to tell me that what I did to you just now is well understood. If it's not understood, then maybe you will have to do a lot of other readings because we may have to proceed and do other things.
Well, except that the one you took before this one, the predictive relevance.
Yeah.
When you were going to start it, you were off just like this. And then later, after about 5 minutes, you came back. And I was wondering whether it is because it is called blindfolding that you are trying to blindfold us.
No. What I'm saying, see, okay, I was checking somebody. Okay, the reason why I just stopped is not because of that kind of blindfolding.
Okay, I just joking.
I saw, yeah, I understand. I saw somebody in the group that he should not be there. You understand? Maybe he didn't pay or something like that. So I wanted to call the attention of our people that this guy should not be part of us. That is why I was checking his name. Not because I blindfolded you.
And I just want to maybe suggest, Kisalis.
Yes.
Actually, I must confess that most of these workshops privileges are very common in Malaysia. I know when I was in Malaysia, I attended so many workshops then with the Amos SEM. But currently, I can say in most of part of the country, maybe other countries, people have no chances to attend these workshops. I don't know if maybe under your network or group, maybe you're organizing this from time to time, but I'm not saying that the fee might be okay for some, but a lot cannot afford. Maybe if for students, something like this can be organized at a lesser cost. I know it's very costly, but maybe that will help a lot because that is what is making people not to be attending, honestly. But actually, people rely more on YouTube because they cannot afford to attend workshops, or maybe there are no experts in their areas, or I mean, in the country where they are residing or studying to learn all these things. And then globally, it is recommended that they must use it. So things like this maybe might help. I don't know.
Yeah. So you see, when we were before the new normal.
Yes.
Yeah, we here, for example, in UEM, I conducted a lot of workshops free. Especially, I could remember there was a time, I don't know if there was a time we conducted one, been conducting like PLS analysis for Nigerian students. I could remember that. Okay, so and that time, let me tell you a story of what I understand. The first day when I was asked to start, we sat down, we designed what we do, and I started presenting. I did so many things. A lot of people were very happy because it touched their study, their analysis. Okay, after the first one, the second, we did it We were doing it every Saturday. Yes, I think so. Every Saturday. Okay. So the first day, 20 people or more came. The second week, 15 come. The third week, I ended. There was a time when I came, I was the only, I and one lady, we were there.
That's why it should not be completely free. It shouldn't be completely free.
So you see, that's the impact of free, right?
Oh, maybe
Yeah, I
Doctor.
understand.
Okay,
I'm
so
not
and
asking
another,
for a free.
yeah, okay, and another thing is that if we can do it this way, license is money, right?
It's money, I understand, yes.
So if you want to buy a license, you just have to buy it as expensive as in Nigeria. You have to get 20,000 naira before you get it, right?
Yes.
You understand? So, but now you are paying, for example, 150, and you get that one free.
Yes, it's true.
It is okay.
It's okay.
Yeah, but maybe next time when we're doing it, we now say, okay, no software. Okay, no, don't
Yeah,
need.
that's
You
another
just
thing. Yeah.
get a way to find the software. Then we
Yeah.
do it as low as it possible. Okay. Yeah. So
Okay,
inshallah.
good. Okay, thank you.
Yeah. No problem.
Doctor, what you are going to do is that those of us that have attended before, we become alumni. And so we get an alumni discount in subsequent edition. When we attend your next program, then we become alumni because we have been part of this. Then we'll be entitled to discount. And maybe by the time you attend 5, you attend 5 and get one free.
Okay, so our chairman, the chairman is here. Hear you.
Okay.
Can hear you.
Yes, sir.
Yeah. So maybe if she can, if the chairman can do something that she had to.
Yes, inshallah. We will discuss about it with my team.
Okay. That would be good.
Inshallah. All right. So please, do you, I don't know if you are really want to learn. If you want to learn this PLS, you just have to attend a lot of workshops. Believe you me. Only one workshop, 2 workshops, 3 workshop doesn't work. I told you the first time I attended my workshop was back to 2016. I don't know if I got 5% of it. I couldn't even grasp it. They were talking, I just listening, looking at them. I see these people, I don't know what they're saying, what they're doing. It's sort of that. So if you want to learn, you should please do it as frequent as possible. Now I was attending last 3 months or 2 months. I attended one workshop from UPM. One guy called Jackie. Jackie is one of the top PLS tutor in the world. Let me call it this way, in the world, because he is no longer dealing with anybody other than people like Ringers, people like a lot of this big name in PLSF. He wrote a lot of papers with them. So he was conducting a PLS analysis, PLS workshop. I attended the workshop. I paid for the workshop. This shows you that it's not that I know everything. There must be somebody who knows more than I know. So I need to go to that person to learn. Okay, so and I want to tell you, I learned a lot of things there that I'm telling you now. Before I didn't know this PLS predict, but when I attended, I learned, and I am learning you. I am making you learn now. So please just try as much as you can to attend a lot of other workshops. If you see any workshop, just try and go. Just try and go. You will learn something. By bit, one day you will learn more than what you expect. Okay, so enough of the advice anyway. Let's go back to business. Okay, so I think we finished this PLS predict, and we found out that our prediction predictive power of our model is very low. No, not very low, but it's low.
Low.
Yeah, but what can you do if it's low? There's nothing you can do. You just report it. You understand? But you should report it and put it in the back of your mind that you have low predictive power. Yes. But in my own case, look at my this. I told you this is a paper I published. No, not published, but sent for review. If you look at this one, it's all of them okay. Okay, so I have achieved full 100% high power. So maybe if you this one depends on how you collect your data. Sometimes you or the combination of your construct. Sometimes you amalgamate some construct that need not to be amalgamated. You will tend to get this kind of prediction problem. So this is it. So and okay, this one is a decision on
Doctor,
hypothesis
screen
is
not shared.
what?
Screen is not being shared.
Oh my God.
It's not doing anything on the screen.
Yeah. See, we okay, let me go back. Sorry. Okay, now it's shared, right? Okay, so what I'm saying is if you look at this is a paper I sent for publication. If you look at it, you will understand that all of them achieved. I have 8 items. All the 8 items, the PLS is less than the LM. So in that case, I concluded that my model has high predictive power. Okay. So I think that's all I said that you did not see. And okay, the next is a decision on the hypothesis. I believe the first at the top we talk about how we decide whether our hypothesis is supported or is not supported. I don't think if you need any clarification about this one, but if in case you need, you can please talk to me. Do you have any issue regarding regarding how you can accept or reject hypothesis? Okay, somebody is asking me, BIF is not mentioned in the slide. BIF is not mentioned in the slide. Okay, which slide? In my slide is mentioned here. Yeah, I don't know which slide are you talking about. Okay, yes. So, okay, somebody is saying definitely it needs to attend almost 10 times. Yes, or more. You will get to know it well, and you put concentration. Above that, you need to love the numbers. If you don't love numbers, numbers will also hate you. Okay, so see, today.
Doctor, we don't have this page in the slides we received.
What? This image?
No, the VIF one.
Okay. Are you sure?
We don't have it. I didn't see it.
You don't have this one?
No.
Have you checked?
Okay. Yes. Yeah. But
Yeah.
But please, you can check by the side. You can you can. Yeah. It's
Sure.
wait. Let me see. It's inactive, so you can make it active there. It's inactive, but it's in my own is there, and I send it to you the same. So maybe you can make it you can make it active. Let me see.
No, the one
yeah. So
format,
you go to number 30 and number 31. Go to the slide, right click and say hide slide. So then the slide will open because it's hidden already. Okay.
No, the one we received in PDF format, not
PDF.
PPT.
PDF format.
Yes, you are right. You are right. So okay,
So I
okay.
think
I
better
will. Don't worry. I will resend it. I will send it.
yeah.
I will.
Thank
I
you.
will. I will give you this one also, inshallah. So okay. So we are here on decision whether supported or support, not supported, rejected, not rejected, significant, not significant, directional, not directional, and so also that. And we talked about it in length there, up there. I don't know if you have any question regarding your hypothesis. Is it supported or not supported? If you have any question or any issue regarding that, please talk to me. I assume you know. I will go further. So, ladies and gentlemen, today we just finished the second part of yesterday. We were supposed to finish all these yesterday.
Ah.
So we have a very long way to go, very long way to go, and the hard the farther it goes, the harder it becomes. Okay, and mind you, it's better to understand something than to listen all.
Yes.
Okay, so please, if you understand what you understand, okay, but I'm not saying don't go, you should go. No, you should put at the back of your mind that you have some age. This is what I understand. Let me just try and understand it more. Maybe when you attend more conference in the, more workshop in the future, you will understand. You will understand it. Maybe when you next time you attend the workshop, you remember it was taught by me this hour today. Then you will catch up from there. So, and in case you need to know more about PLS, this is one of the, these are some of the books that you should have. You can use, you can have 3 of them. 2 of them can be, you can have 2 of them online, but the other one written by Ramaya is still not online. You have to purchase it and hard copy. And by the way, in this workshop, I will try to give you the 2 books. The one that is in soft copy, a primer of partially square modeling and advanced issues in PLSN. I will give you these 2. I will send it to you to your emails. Maybe if you get time, you read them. It's okay. But if you read them, you find them very interesting because they are very good, well written books.
The doctor is showing you already having that.
Huh?
There is one doctor, he's showing you the both books, hard copies in the video. Dr. Odukoya. Yeah, he's showing. Yeah, doctor, you have already. He's showing in the video both books.
Oh, okay. Maybe I am not here, so I cannot see it. Okay. Okay, so it's okay, but having the hard copy, I will still give you the soft copy if you want it anyway. I will send it to your email.
Yes.
Yeah, you read you read it. You read it, inshallah.
Thank you very much.
Yeah, it's gonna help you, inshallah. So this is the end of the first segment. We are moving to day 2. You see, now we are into day 2. Today, our day is no longer 24 hours. We have almost 38 hours. 38 hours now, the one day. And unfortunately, the second day could be only 3 or 4 hours. So, but we will try to finish as much as we can, inshallah. So, but we assume that you understood the first day. We move to the second day. So the second day is going to be something very, very interesting. We are going to talk about mediator, moderator, higher order, and the IPMA. So these ones, they are very important because, for example, for writing now, for paper or thesis writing or article, if you're writing article, nowadays, if you don't include mediator, moderator, or you don't use higher order, please don't send it to higher journal, high impact journal, because direct relationship is already saturated. It's very unlikely now you can get a construct that is not tested, retested, and over tested. So that is why using mediator, moderator, you can have edge. Immediately you write, you make your argument very clear, very okay. You will be cited, you will be published. All the papers I did, I have never used I have never reported a paper that is not direct relationship. No, all of them either mediator or moderator, or I use higher order and include mediator or moderator. Okay, so somebody is saying, please, we should try and send the recording. Okay. No. We are stopping 1 o'clock today. Okay. So please, Madia's normality, we will do it, but please, we want to finish the basics first. Yeah, yes, we are going to cover it. We are going to cover it, but please, we have to finish the most important. Yes, Madia's is just a normality test, which you can send your thesis without a normality test. Nobody will care. But if you send without mediator or moderator, definitely you know what you send. So see, okay, the first thing that we do is we're going to talk about mediator. Okay, this is mediator. This is typical example, typical representation of mediator. Mediator is we are introducing another variable. We are introducing the third variable, and this is how it is. Okay, a mediator is a third variable that explains how and why two variables are related. In mediation, the dependent variable causes the mediator. The independent variable, I beg your pardon, causes the mediator, which in turn causes the outcome. That is a change in exogenous variable, that is a change in the IV cause a change in the mediator, which in turn result in change in the DV. That means if you look at the figure below, Y is your IV, M is your mode mediator, and Y is your DV. So we are saying Y, change in Y cause change in M, and change in M cause change in Y. Okay, Y2. Cause in Y1 and change in Y1 cause change in M, and change in M cause change in Y2. That is what this paragraph is talking about. A simple mediation model consists of one IB, one DB, one mediator. Okay? Mediation occurs when a third variable intervenes between the two or more constructs. This is about mediation analysis. So, ladies and gentlemen, in mediation, there are so many tests you can do. There are so many tests you can do to test mediation. There is Baron and Kenny way, there is Sobel test, there is bootstrapping, there is Bayesian estimation, there's Monte Carlos, and a host of them. And a lot of them are being challenged, especially for Baron and Kenny and Sobel test. All of them being challenged, or even Monte Carlo also was being challenged by other scholars. But in this case, in this present workshop, we are going to use only the bootstrapping method, which is by Preachers and Hayes 2004 and 2008. So there are so many approaches if we want to do mediation analysis. The first one is a causal step approach. That is according to Baron and Kenny. What he's saying is that we want to know if we want to know whether M mediate the relationship between X and Y, we have to make sure that we have to test the effect of X on Y. That is the effect of mediate IV to DV. Then the next, we look at the effect of IV to mediator. Then we look at the effect of mediator to DV. Then we say that mediator, if there is mediation, then we say M mediates the relationship between X and Y.
Yesterday, Dr. Salis, yesterday we referred that dependent variables and mediator could be considered as endogenous variables.
Yes.
So in this case, we are measuring the effect of the exogenous on the endogenous.
No,
and
see, don't confuse yourself with that indigenous and exogenous. Just concentrate on mediator DVIV. It will save a lot of time for you.
Yeah, but because yesterday when you let us say refer to them, you said simply that exogenous are the independent variables.
Yes.
And the endogenous, they include the dependent variables moderator and mediator.
Yeah, exactly.
Okay.
So, yeah, no problem. Yeah, exactly. So this is the Baron and Kenny way. Then there are two other ways that were newly introduced in 2004 by somebody called Ngutu Sanam in 2014. He said he said there is two approaches to mediation, to mediation hypothesis anyway. The first one is segmentation approach. What is segmentation approach is that you test the effect of X and on M, then the effect of M and Y, then you test the mediation. That means there is no effect of X on Y. Do you understand? No,
yes.
The issue, the direct relationship between Y and X and Y is not there. If you are testing the relationship between X and Y, X and M, M and Y, you are doing Baron and Kenny. But if you are testing the effect of X and M, then the effect of M on Y, then you test for mediation, you are doing segmentation approach. You don't care whether the X and Y are significant or not. You don't give a damn to that. Then there is what they call transmittal approach. It's also by the same person. You don't mention whether there is effect of X and on Y or M on Y or X on Y. Your hypothesis will say the first thing, you have only one hypothesis. M mediates the relationship between X and Y, and that's it.
And does it happen that in the study or the research, the PhD can be, both those steps can be used?
Okay, yeah, that is, we are talking this general term anyway. But when it comes to the issue of PhD, I always advise go by what your supervisor wants. If your supervisor say go for causal approach, test all of them, let them be significant before you move into mediation, do that. But you should not that you are following Baron and Kenny. And maybe in the subsequent table we'll talk about Baron and Kenny. You know what why he should not be followed any longer. Okay, so but if your supervisor asks you that no, don't test the relationship between your IB to DV, just go IB to mediator, mediator to DV, and leave it like that, and test for your mediation. But in this case, you should know that you are doing segmentation approach. But if your supervisor asks you, please, we don't need all the direct relationship in our model. We only need mediation. Just report mediation, no mediation. Your relationship between IBDV, your IB mediator, mediator DB, we don't need it. We only need mediation. Mediate or no mediation, that's class. That means you are doing what's called transmittal approach. Yes. Okay, that's it. Then there is an issue that was before there's what we call full and partial mediation. A lot of people before they report full and partial, if there is full, what is full and partial? What it's saying is that if the relationship between IV and DV is negative when you introduce mediator, then there is full or complete mediation. That is when it renders insignificant. But when it's still significant, but the significance level is reduced, meaning that now you say there's partial mediation, if there is mediation at all anyway. So, but in 2013, Hayes challenged that. He said full or complete and partial mediation are outdated 20th century concepts that have no place in 21st century mediation analysis. If you can challenge that one, you can maybe add something and change it. But I agree with them anyway, because there are so many ways that you can, you don't have to say partial, full, or or complete. So recently again, somebody Zhao et al., that's his name, Zhao et al. 2010, come up with something new, that instead for you to say there is full or partial or complete mediation, you use what is called complementary versus competitive. So that is how you do it. Number one, if boards, okay, you look at the diagram below, P1, P2, P3. Then we are going to use this one. If P1 multiplied by P2 and multiplied by P3 are significant, that's one condition. Then you determine the sign. If the sign of P3 is negative, okay, if the sign, when you multiply and the sign is positive, you consider it as complementary mediation. But if you do that and you find it to be negative, you conclude that you have competitive mediation. In the case of Baron and Kenny, you don't need any competitive complementary. They all have to be positive. If positive, positive, positive. So that is why they say he need not to be taken into account any longer. So this is one of the diagrams that you should understand. If you run your model, you now look at you multiply A and you multiply the part between IV to mediator and the part between mediator to DV. If it's significant, then you now say, is C significant? That is the relationship between IV to DV is significant. If it's significant, then you now say, you still ask, if you multiply a part coefficient of the relationship between part coefficient of x to m and part coefficient of m to y and part coefficient of x to y, are they positive? If they are positive, then you conclude that there is complementary mediation. We are just repeating what we said earlier. So that is how. If it's not, then there is no mediation. You just have to report that there is no mediation. So this is some of the scenario that you find when you are using complementary and competitive. When you run your model, mediation model, and you find out that the relationship between x and m and y, and x and y, they are all positive, 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 you say your mediation is complementary. That is, if the mediation hypothesis is significant. Or if you have, okay, look at this way. When you multiply x plus plus multiplied by plus multiplied by plus is plus. Plus multiplied by plus also is plus. So it's plus, so complementary. When you multiply negative times minus times minus times plus is minus. Minus times minus is plus. So it's complementary. When you come to this one, plus times minus is minus. Minus times minus is plus. So is complementary. When you take this one, minus times minus is plus, and plus times plus is also plus. So you take it as complementary. We will show when we run the model, you see it. Then the next is in the competitive aspect, plus times plus is plus, but plus times minus down is minus, so it's minus. Then the second one is minus times plus is minus, minus times plus is also minus. Plus times minus is minus, minus times plus is minus. Minus times minus is minus, is plus, plus times minus is minus. So that is the scenario that you can find if you are using complementary mediation. So this is mediation. We are going to start mediation on the screen for you to see. Before we do that, any question? Do you really understand? Please, I want to hear from you. Do you, ladies and gentlemen, understand?
From this section, understood.
Okay, so I want to hear more.
Excuse me. I have one issue, sir, regarding mediation. So, of my supervisor told me use any approach. So, in this case, should I use Baro and Kane or segmentation?
No,
your advice. I want your advice.
No. See, your supervisor give you choice.
Yes.
So, if your supervisor gives you choice, run your model and see which one will give you better significance. If whichever give you a better result, then you go for it. That's my advice. Yes.
Okay, sir. Thank you, sir.
Inshallah. Any other person? Ramash, are you with us? I want to believe. Please don't run away. We are still having more delicious delicacies here. So please don't run away. We are still doing it, and it's very interesting to see. To me, anyway, I don't know. Okay, so we are going to model mediation. How? We are going to use the same data, same model. We don't change anything. How are you going to do it? In this case, we have, how many IVs do we have? We have 4 IVs here. We have 1 DV. So we want to try and make 1 IV as a mediator, for example. And we will prove to you this is okay. Then, because you don't know, you cannot just say, okay, I want to use this as mediator. You have to have a kind of what the instinct. Yeah, you have to have the kind of good instinct that gives you this is really a mediator. Okay, not just any construct that can be a construct can also be a mediator. No, let's choose trust as our mediator, and
something makes sense.
Yeah,
something makes sense that
it should make sense that it's really can really be a mediator. Okay, so this we have three IVs now, and we have trust as our mediator. So, but for us to know whether it is mediator on the model, on the framework, we have to connect our IVs to mediator.
That's right.
IV to mediator, IV to mediator. So this will tell us that we may want to test this one as a mediator. Okay, so what it is saying is that if we want to use, if a customer want to use a mobile banking software, he look at the security. Then the security will lead to trust. Then trust leads him to use. Does that make sense?
Yes.
Eh?
Yes, it does.
Yeah, because if you look for security, you are not looking for security alone. You just having the security is not enough for you to just say, okay, I use it. And it's not enough. I just have to, okay, I trust it. It has security. Okay, next is for me to trust. Then if I trust it, I use it. Do you understand?
Yes.
Yeah, something like that. Okay. That is it. The software has privacy. Is very good. To customer satisfaction, that the privacy is very short. Then the next things the customer will do is to trust the software before he uses it. So in the case that, meaning that there must be trust between privacy and use. It's not that you perceive the security of that the privacy of that software that will make you use it. No, you have to trust it first. That is how you understand how you use a mediator. Not just like that. Okay, let me give you another example that will make it very clear. There is what you call reward. That is a reward. That is something like salary, something like wages, something like bonus, something like overtime. It's being given by your company. Okay, so and we want to see whether this reward that is given to you will make you satisfied, will make you perform your work effectively. It's not possible that just by giving you salary, it's not 100% assured that you are going to perform what is required of you. The thing that will give you more, that will give you assurance that you are going to perform is, do you really satisfy? Are you really satisfied with the reward given to you? If you are satisfied, that's then will you perform. In that case, satisfaction is your mediator. Another way, another example is that there is, we also we are gender, male and female, and we are certain that there is always a relationship between two of us. Between male and female, there is a relationship. Okay, when it comes to the issue of a friendship, a relationship between female and female, for example, So if male and female, okay, no, that one is should be me moderator. No, that one. Okay, this one is okay. We can talk that one later when we come to moderator. This one is we're talking about mediator. Okay, so this is a clear example, two examples that you should understand what the concept of mediation. So if you want to test, you want to model the mediation in PLSM, this is how you do it. You connect all your IVs to mediator, you connect all your mediator to DV. But this is where the issue is. We have connected all our IVs to DV. Then what are we following? Are we following Baron and Kenny or who?
Baron and Kenny.
That is great. So in this case, if we leave it like this, we are following Baron and Kenny, the causal step approach. This one, we test this one, we also test this one, we also test this one. This is our how we put our hypothesis. But if we don't react this way, we remove.
So, and Dr. Salis, in this case, yani, we are using two approaches for such models.
What do you mean by two approaches?
The segmental one and the causal relationship one?
No. So this one is causal approach. Causal approach. Yeah. So, but if we delete this one, we delete this one, we delete this one. Now we are using what? Segmentation approach.
That's right.
Okay. If we decided to just say, what's the name? Transmittal approach, you don't need to show it here. You just run and say you don't need the relationship. Okay, if you want to test mediation, there must be relationship, direct relationship, but it's your hypothesis that will determine what and what do you want to report. If you want to report only mediation, that means you are doing a transmittal approach. If you want to test only a direct relationship between IB to mediator, mediator to DB, you are doing segmentation. If you want to test all the relationship between IB, DB, IB, mediator, mediator to DB, that's when you're doing causal step approach. So in this case, we want to make our own normal way, the way that we know in that we've been used to here. So this is a typical model. We model our data based on 3 IVs, 1 mediator, and 1 DV. The next thing is we want to run and know whether it's significant or not significant. Okay, in this case, we are doing, we are going to repeat the same thing we did before. Okay, somebody is asking, let me see. Okay, somebody is tired, he's asking of time to go on break.
Yes.
We will go. Okay, so inshallah we go by 1 o'clock, but we make sure that we finish mediation before we leave. Okay, I think 8 minutes to go, no problem. Yeah, congratulations. Very soon you're going to.
Sir, excuse me.
Yes.
So, are we using now the repeated indicator approach?
Please, we are not. We are still doing
mediation.
Mediation. We are not up to that level. We told you when you see something like this, when we say higher order construct, that's when we start talking about a repeated indicator, whatever. In direct relationship mediation or what have you, we are not talking about it. Do you understand?
Okay.
Yeah, please, we just relax. We are coming to that.
Sorry. Thank you.
I want to believe you have it in your model anyway. Okay. So this is the model, typical model we draw the next thing is we want to test whether the mediation is significant or it's not significant. In this case, we just the first thing we do is we don't need to run for calculate PLS algorithm. No, we don't need that. The reason is that we are not looking for the relationship between IB to DB. Directly, we just go and say bootstrapping. And here, if you remember, I told you, if you are doing mediation, you must use two-tail. So in this case, it's two-tail always, not no one-tail. Okay, when you click one-tail, all other things remain the same. You now start calculation.
Please take that again, sir.
Okay.
We pick two-tail.
Yeah, we pick two-tail. This bootstrapping, we pick two-tail. When you are running for mediation, you two-tail. When you are running for moderation, one-tail. When you are running for direct relationship, depends on how you state your hypothesis. Is your hypothesis directional? One-tail. Is your hypothesis non-directional? Two-tail.
Why? Can you explain? Why, for example, for mediation only two-tailed?
See, this is how it is. Okay, don't if you ask okay, somebody asked me that same question, and I was able to ask Maya. The guy was he did his viva, and he told them that he used two-tail in mediation, and he was questioned. He gave us the reason why. So and he come to me. I didn't know then. So I say, okay, I will ask from Ramaya that. I text from Ramaya. He said, you don't need any justification why you choose two-tail. Mediation is always two-tail. So let me give you the same answer he gave me.
It's just it's a procedure like that. Huh?
Yeah, it's a procedure. That's how you put it. So, okay, so the next you say start calculation, you now started calculating. Okay. Okay, when it finishes, you don't need to look at your model because your model will not tell you anything about your whether it's significant, the moderation is significant or not. All it tells it will show you here is a direct relationship, and you don't need the direct relationship. In this case, you go to report. Under report, you go to final results. Down, you will see specific indirect effects. You click there. Okay, when you click there, what do you see is your result. And here you would do the same way we did in the previously, that we look at the t-value and p-value and the confidence interval. Okay, so in this case, when we look at this one, which one is significant, which one is not significant? Don't just look at the color. Tell me why it's significant or it's not significant. Anybody?
Yes, sir. The first hypotheses are significant. The last one is not significant. The security.
Why?
Due to it is more than 0.05.
Which one?
The last one, the security.
Security.
Okay, so you are talking about p-value, right?
Yes, sir.
Okay, so only p-value okay enough?
No, as well the original sample.
No, original sample doesn't matter. Now, what matters is the t-value.
Yes.
T-value, t-statistics and p-value.
Yes,
and the confidence interval. So, but here we look at the t-statistics. The t-statistics is, we look at it the way I showed you before, that one tail must be significant if T test, T value is 1 point, what?
96.
1.64.
1.64, exactly.
645.
1.64,
So,
yes.
but if it is two-tail, 1.96 is what? It should be 1.96, right? And above.
Yeah, I think so.
T value must
Yes.
be above or greater than 1.96 for it to be significant if you are doing mediation. So in this case, if you look at the T statistics here, they are all 2.3 is greater than 1.96, 2.3 is greater than 1.96, 2.7 is greater than 1.96. In this case, these two are trust mediates the relationship between authentication and use. Trust mediates the relationship between privacy and use. But because T value is less than 1.96 in the case of security, we have no any mediation here. Do we understand? Yes. So, and this one, even if you don't report confidence interval in a direct relationship, in mediation is compulsory that you must report confidence interval, and it's got the same way that if there is no zero in between, you consider it as significant. If there is zero in between, you consider it non-significant, and that is how it's being interpreted. What next is, I think that is it for now. I think, okay, we finish mediation as quick as we can. All right. So, ladies and gentlemen, this is all about mediation. If you have any question, ask before we go for break, 1 good hour. We are coming back 2 o'clock, inshallah. If you have question, we have a good 5 minutes to talk about to respond. In this case here, I don't see any question or tax.
Okay. Quickly, just a recap of what to report in mediation result. Quickly,
Yeah.
please. Sorry.
Okay. What you report in mediation result? You report this. You report when you go here. That is specific indirect effect. You report. You go to mean, standard deviation, whatever. You copy all of them. Okay. You report sample mean. Sample mean is called beta value. You take standard deviation. You take T statistics. You take P value. Then you go to correct confidence interval bias corrected. You take lower level and upper level. This is what you're going to report.
Okay.
Yeah.
Okay, that's it.
Inshallah. So, any other question?
Sir, excuse me.
Yes.
If I have 2 mediation, should I use the same process?
Yes, you don't have problem. Same two mediation give you no problem. Yeah, just run, connect them and run. It will give you the same result. No problem.
Thank you, sir.
And then, sir, for this, the interpretation of complementary and competitive here.
Yeah. Okay.
For
so
this model.
Yeah, you look at it here. Okay. In this case,
Okay.
you just calculate run PLS algorithm and say
Algorithm. Okay.
Now you look at one by one.
Okay.
Let's just give them space so that we know which one is one by one.
Okay.
So now we look at this one, security, trust, and use. We now look at security, the relationship between security and trust. That is, if it's significant. Is security significant? Yes, right? So security here is negative. The relationship between security and trust is negative. But the relationship between security and trust and use is positive. And the relationship between security and use is also positive. Now we multiply. Positive times negative is negative. Negative times positive is negative. In the case of security, we now say is competitive mediation. The second one, we have this one is all authentication. They are all positive. So in this case, we say is complementary, and that's it. Because the last one is not significant, we don't need to even talk about it. I think that this one made sense.
Sir, excuse me. Should we report the F square and R square in this case?
See, okay, how can here? How can you know which R square and F square are you talking about? You don't need R square, F square here. Okay, you need F square, R square if you have everything in the model. For example, this is okay. You have mediation and the DV. DV and mediator are all endogenous variable in this circumstance, in this case. So in this case, meaning that you need to report the R square of mediation and the R square of DV. Do you understand?
Yes, sir.
Yeah, you need to report the R square of trust. You need to report the R square of use. What is this saying is that if you are talking about the total contribution of these three IVs to trust and the total contribution of all the four, including trust, to use. So this one, in this case, authentication, privacy, and security explain 42.6% of trust, while privacy, authentication, security, and trust explain 31.8% of use. I think that is how it should be.
Okay, sir. Okay, thank you, sir.
Yeah, that's it. That's great. That's great. So, any other question?
So, Dr. Salis, now I just want to make sure such model you are giving now, it doesn't follow the segmentation approach. It follows only causal step approach.
Yes. So maybe we can let's try your own and see. We want to try this one.
No, because you know what, I'm comparing what you are saying to my
Yes, that's what I'm saying. We are removing this one. I think this is called segmentation approach, right?
Yeah, because it.
Yeah. So now we just see. We now say PLS. Oh no. I beg your pardon. We now say calculate bootstrapping, and now we now say two-tail, and that's it. So, and that's it. That is how you do it. And in this case, you just go to report and now go to specific indirect effect, and you see.
All of them are significant.
Now significant.
Okay.
Yeah.
Because I'm comparing what you are explaining to my model. So that's why I'm just comparing what you are saying.
Yes, I understand.
Okay. And we will discuss it later, definitely, yes.
Sir.
Yes.
For the using one tail or two tails, so the significance level should be changed or same 0.05?
I said again, sorry.
When I use one tail or two tailed, so the significance level, is it still same 0.05?
See, there are two things. You are using two tail, but your result will now tell you whether it's significant at one tail or at 5% or 1%. There are two different things. Do you understand?
Yeah. More elaborate, sir. Can you elaborate more of
Yeah, see.
After Asad,
please wait. Let me meet this guy.
He's the one that can do it for you. Don't waste your time. So after Asad, since you already have discussion with him, just complete it. I'll remind him.
Okay. So what I'm saying is, when we say the level of significance at 5%, meaning that if we have 1.64, we say is significant at 5%, 110.
Mhm.
You understand?
Now, yeah, now clear.
Yeah. So if it's significant at 1.96 at 110, we now say is significant at 1%.
Clear, sir, clear.
Yeah, that is how you do it.
Thank you,
Okay,
sir.
Yeah, yeah.
I think it's better we proceed for the break now.
Yeah, so please, ladies and gentlemen, maybe we go for a break. We come back by 2 o'clock and we proceed from there. Thank you for listening to me. Assalamu alaikum.